Hello
Having
and
a technical
greetings.
issue.
Here is Joscha Bach. I started initiative a few years ago. The California Institute for Machine Consciousness is trying to understand how the mind works, and it's mostly looking at this delta between what we currently have in our understanding in AI and where minds are and how minds operate. The reason that I entered artificial intelligence was that I was really curious about how our minds operate, and one of the first questions that I had is how is it possible for a system to feel, to experience anything, to have an experience of itself and of reality? And so for a few years, I worked on models of emotion and motivation and adopted theories by several psychologists, most notably Dietrich Dörner, that basically propose a cybernetic model of motivation and a space of modulators that configure cognition and the way in which self-modeling works in such a way that we experience ourselves in different ways when we are configured differently. So one way of thinking about this is that our mind is a universal modeling system that is coupled with the world that it's motivated to model. And as a result, it builds something like a game engine that is modeling a three-dimensional world with lots of agents in it in real time. And one of these agents is yourself. And that agent is an entity with a body, with the ability to model, with the ability to perceive. And minimally, it's an observer that is confronted with a reality. And that observer itself is a simulation or a simulacrum. It's basically a little homunculus, a doll, a puppet that the mind is creating to tell itself its own story in the world. And it confronts it with motivation and experience as a simulation of what it would be like if that puppet was a real agent and existed and cared about it. And we, the puppet, find ourselves confronted with the problems posed in this way and have to respond to these things in real time. And the output of this behavior that the puppet is generating is in part being used by our outer mind to drive the organism, to orchestrate the behavior of trillions of cells into a single entity that behaves in a particular way. And for some reason, this affair, which is relatively straightforward, once you see it, you cannot unsee it. That's clearly how it works, seems to be mysterious. And a lot of people find that this mystery is inscrutable, and they've given up on it, researching it scientifically, to the point where it's not much discussed in psychology textbooks and in neuroscience textbooks and in the general canon of our culture. And I feel that we need to go to the root of how the generation of the mind and the self actually works, the generation of experience and so on. And the most important open question is, what is consciousness and how does it work and what is it good for? If you think that consciousness is very mysterious, that's also an interesting question. What does it mean for something to be mysterious? Generally, I think to be mysterious for most people means two things. One, it is very, very significant, which means I feel that it's very, very important. It has deep connections to the root of my being, to what motivates me, to the things that are sacred to me, the things that I'm willing to sacrifice my ego for, and so on. And on the other hand, I don't understand it. And the fact that I don't understand it seems to be somehow entangled with the mystery itself. So it might even be important that I don't understand it. And we have some underlying fear that if we were to understand it, the mystery might disappear, which might mean that also the sacredness, the source of meaning that is embedded in it, might disappear, that it basically becomes secularized, that it becomes trivial, that it becomes mechanized, that it's something that is disposable, and that I myself might become disposable. I don't think that anything like this is the case. I think it's very similar also to understanding music. A lot of people, before they study music theory, are afraid that if I understand the theory behind the music stops being interesting. And instead, what happens is that you get to a much deeper level of interacting with it, and you get to appreciate it much, much more. So in this sense, I believe that understanding consciousness is very much like understanding music or understanding kissing or understanding food, right? So the more you understand, the deeper your relationship to it becomes, and the more significant and interesting it becomes in a way. I don't think that consciousness itself is very hard to understand. It's a particular kind of representation. I think we can understand it as meta-perception, as perception of perception. And it's not that there are just percepts available, but you also need to notice that they are available. And this perception of second order is what makes consciousness a little bit harder to understand than the perception of first order that, for instance, a self-driving car might have. A self-driving car is necessarily classifying its environment, the features that it finds in its environment, and is checking which ones are present and how they relate to each other. But the way in which this is done is basically ensured by the nature of the learning algorithm that the self-driving car is using. And this learning algorithm is deterministic, and it's imposed on a deterministic substrate that you can force to do what you need to. You tune the algorithm until it does exactly what it does. In our own mind, the learning algorithm needs to be self-organizing. It needs to be some kind of order that is creating itself and enforcing itself and adapting to disturbances that it might have and differentiates itself until it gains the resolution and depth that it needs. And I suspect that the principle that drives this is the creation of coherence, which is a semantic criterion. It basically means that all the different features that you are modeling are compatible with each other. In this sense, we can understand consciousness as a consensus algorithm, not too dissimilar what happens, for instance, on the blockchain. The blockchain is an idea that was invented in the context of cryptocurrencies largely. And the problem that needs to be solved for these cryptocurrencies is decentralized agreement on what's the case, namely which money is in which account, in a system in which lots of the transactions are happening decentralized and in parallel, and there is no centralized authority that can control them all like a central bank. Instead, there needs to be a system of distributed ledgers, of distributed databases that agree on the same reality. And this synchronization across an unbounded number of decentralized nodes that don't have centralized control, that each are self-motivated, not too dissimilar from the individual cells in your brain, that is a mathematical problem that needs to be solved. And I suspect that our consciousness is an algorithm that emerges at the beginning of our intellectual career when our mind is being built as part of this organizing principle that makes us grow a mind, that is the prerequisite for our cognitive architecture that turns us human. I call this particular aspect of consciousness being at the beginning of our mental development as the thing that is creating the world and the mind in our own brain. The Genesis hypothesis. It's basically the idea that consciousness is this primordial spirit that creates the world. And what it creates is, of course, not the physical universe. It creates a game engine that is modeling geometries and people and colors and sounds and visual expressions, right? All these things that we motivate in the world and that we see in the world, that we care about, that we are interacting with, and that are to a large degree not physical entities, but there are motivational, relational entities that are represented in our own minds as models of what the organism should care about. And consciousness is basically a pattern that is colonizing the mind and turns it into this architecture. Another important aspect is that consciousness is making us coherent, that it steps in whenever our mind is disharmonic, when our model of reality falls apart, and our bubble of coherence, this bubble of now that we inhabit, is threatened with falling apart, similar to the music in an orchestra where the instruments become disharmonious and so on. And at this point, the conductor of the orchestra is stepping in, and it directs attention on the instruments that are in disharmony and resolves what's happening between them. And this is this conductor role of consciousness is what I observe my consciousness to be doing in real time when it is dealing with the music of my mind and make sure that all the instruments that are producing this symphony of perception and reality that I experience is coherent and all the instruments are on the same page. I call this aspect the conductor theory of consciousness. And what we observe introspectively is that consciousness is perception of perception. So it is a second order perception, a meta perception of a real-time interaction with yourself and the world. I feel introspectively that my conscious attention is flipping back and forth between the contents of my perception, between the features that I'm looking at, that I'm interacting with, and the fact that I am conscious of them. So it's itself a percept that I'm having. It's not an inference. It's not some kind of logical reasoning that allows me to perceive that I'm conscious. I perceive that I'm conscious immediately. And this fundamental difference between reasoning and perception seems to me that perception is synchronous. It's resonant with reality. It's happening in real time. This doesn't mean that it's happening instantaneously at a point in physical time. It's, of course, a protracted process that requires a number of steps across several layers of neurons in my brain that are operating in cyclical processes and thereby producing these wave-like patterns that you can catch in an EEG. But what happens is that these patterns evolve in the same timeline at the same rate as what they're modeling. So we are becoming resonant with the things as they happen around us and inside of us. And our models are trying their best to be in sync with the stuff that are modeling. And so from this perspective, we can understand our mind as some kind of resonator with the world that is resonating in a very detailed and fine-grained way with modeling reality. The theory has been expanded upon in detail by Grossberg in his adaptive resonance theory, which is a very interesting body of work that he has developed, mostly in his time at Boston University. And it's a very interesting alternative perspective on how computation can work using coupled oscillators. But it's a line of thought that people have mostly developed in the orbit of neuroscience. In AI, we are not looking at these things very much because the core theory that we are using is a perceptron learning at the moment, and in a way that's quite ironic. As we have seen in the last few years, until the 2010s, I think AI was something that most of the public saw with great skepticism. And that's surprising because the ingredients for today's AI have been available for a very long time. For the greater public, I think the big aha moment happened in 2020 with GPT-3, when this widely publicized large language model, which was already in its nth iteration, right? It didn't start with the GPT-1, it started with earlier systems, like BERT and so on, machine translation systems that were used internally at Google. But at some point, OpenAI decided to take this algorithm, run with it, and see how far they could scale it up. Then they built a system called GPT-2, which showed that the scaling actually works and that they would have something. And then they turned this into GPT-3. And GPT-3 was then published in 2020 with very big fanfare as the thing that is now heralding the AGI age. And people were iterating and oscillating between observing that this thing is really big and significant, and it does things that nobody really thought was possible up to that point, or a lot of people didn't think that it was possible, and a lot of skepticism. Is this imitative statistical learner actually AI? But since this thing has happened, it's only 6 years ago, or 5.5 years ago, the world has changed dramatically and has changed faster than we can keep track. And so our perspective on AI has changed. And it's not just the general public that is surprised, but I believe also most of the practitioners of artificial intelligence are surprised by the thing that we've gotten. Because the thing that we've gotten is very unlike the thing that we would have thought we would get. It seemed to me, working in AI research over many years, that there were largely two camps among the people who did actually believe in artificial general intelligence, which was not even the majority of the field, right? Most people were skeptical about the near-term prospects of building systems that were human-like. But those that believe in it, I think the majority thought that we would get there by building lots and lots of incremental modules, that there would be basically generations of researchers that slowly unravel many, many puzzles inside of the mind and put the solution together into a system that together with all these parts is emulating the modularity of the mind and is then producing all the skills that are necessary. There was also another camp that was basically hoping for some kind of master algorithm, something that would grow itself to intelligence from a very simple seed, and that would work from first principles, basically from logical, analytical reasoning. And it would start out as something that's much smarter than us, but knows very little and might have, for the first few years maybe, difficulty to deal with the real world, with common sense, with things like moving a body through the world, with the heterogeneity of the world, with the vagueness of perception. And what we got is very different. We got a thing that is pretty good at common sense, that sometimes makes stunning logical mistakes, that has read everything, and basically knows everything. It's a artificial idiot savant, something that has very weird, unusual, unhuman-like skills. And it's also a thing that lives in an isolation tank. It's something that is not coupled to the world. It does not get to experience the world as it evolves in real time. And instead, it's asynchronously to it, much more akin to our analytical reasoning. And because it lacks this direct coupling, it is behaving in a similar way as we are when you put humans into an isolation tank. Humans tend to hallucinate when this is happening. When we get divorced from our perception, our mind spins off and it generates a world of its own that is no longer grounded in a fixed reality, and it is at some point drifting apart and is no longer coherent. And so that's an interesting question. If we want to make these AI systems coherent, do we need to take them out of the isolation tank? Do we need to couple them to the world? And these thoughts existed in the 90s, for instance, in the context of new AI, where a lot of people were thinking about embodiment, but the techniques were not at the level where you could scale up learning and real-time learning into embodiment. And even now, it's an issue that people just begin to tackle, that we do real-time continuous learning is a very important and open-ended era of research that is largely still in front of us. And so what happened in AI is in the mid-1950s, when Marvin Minsky, John McCarthy, and many others started the field, influenced also by ideas by John von Neumann and Alan Turing, they had this idea of teaching computers how to think via programs. And then they spawned off this revolution of many, many methods and ideas in AI research. And when they started, we basically already had the ideas of perceptrons and feedback. And now it turns out that this idea of perceptrons and feedback, of simple neural networks and feedback and optimization of this, is all that was necessary to build these large-scale models. And almost everything that we did in between in artificial intelligence was not even on the critical path. That's very surprising. And there's an interesting question: are these systems that are able to solve the Turing test, this big perennial problem that Alan Turing has given? Can we build a system that convinces the interlocutor that it's a human being? Is that best by imitative learning? Is the statistical learner really the thing that we were looking for? Or is there something important missing? And is that thing conscious? So there is this question: does this causal pattern inside of the system, is this deep enough? Is it accurate enough to be equivalent to the causal structure in our mind? Again, as I said, I don't think that consciousness is mysterious. It's a particular kind of representation that solves a particular kind of purpose. It seems that this purpose that it serves in us, that it's this conductor of reality, that it's the seed function of reality, that it's necessary to make us coherent, is not important for our current AI architectures. I don't think that the current AI architectures, when they produce output like a text return or a piece of code, are conscious while they do it. They don't need to be conscious to do it. You need to be conscious if you want to write a piece of code. The AI doesn't. But that's because your architecture is self-organizing in the way in which the AI is not. But if you ask the AI to simulate what it would be like to talk to a conscious being that experiences itself, then the AI needs to reproduce some of the structure. It's important to realize the reason why the LLMs work is not because they are producing just pastiches of words that are statistically similar to the streams of words that I've seen in the training data, but they need to reproduce deeper structure behind it. When you are writing a text about a mental rotation task, where you say you have a room that is full of furniture, you rotate the contents of this room by 90 degrees, what does the room look like right now? Then internally the model has to perform all these operations, which means it needs to simulate a space with objects in it, and it needs to mathematically model the operators that are necessary to move these objects to their new locations, and then generate a model of what it looks like from this new vantage point, and it gives you the output. And it turns out that with enough training, our language models are able to do this, which means they don't think in words or in tokens, they think in a deeper reality behind them that connects them. It's the same reality that humans are talking about when they are writing these tokens into the training data in the first place. So in the same way as the LLM needs to learn spatial reasoning when it's writing a text about spatial reasoning, it also needs to learn theory of mind when it's writing a text about human mental states. And when it writes a text about its own mental states, it needs to create a simulation of a self that has such mental states. And it's a very interesting and somewhat open-ended question at which point this is just a text and because very often it is just going to be words, and at which point the causal model is indeed akin to the deep structure in your own mind. And I have not seen a very good methodology to do this. But it seems to me that the best way to ask yourself if a technical system is conscious is the system being conscious the easiest explanation for what it does? This question is somewhat similar to the question, is a cat conscious? Right? You cannot easily ask a cat about its experience and then it describes what red looks like to it and what it's like to be a cat. But what you can observe is the cat learns in similar ways to you. It also requires to be wakeful and alert and integrated. And it appears that the cat seems to have a model of itself while it's observing and is aware of the fact that it's observing things. And so it would be possible that the cat has develops behavior similar to us because they're hardwired, because they're all instinctive, but ultimately it would be much, much harder to hardwire all these behaviors into the cat than get the cat to discover the same mechanism that makes us conscious. And so if consciousness itself is an algorithm similar in complexity to, say, the transformer, something that can be discovered by a search process in the brain, and it's more complicated, less complicated than the things that you learn using consciousness, that you learn in the perceptual world, in the world of actions and so on, while being conscious, through being conscious, then it makes sense to say it's much more likely that the system starts out with being conscious in the same way as us and acquires all these things later on. So this leads us to this machine consciousness hypothesis. The machine consciousness hypothesis that I'm currently pursuing has two parts. The first part is a hypothesis about biological consciousness. It says biological consciousness is best understood as some kind of a self-organizing learning algorithm for self-organizing systems in nature. And it's implemented, as far as we know, in the communication patterns between cells and other biological parts. It's probably largely a pattern in the interaction between neurons, but whether it's other cells are being involved, and to which degree they're involved, and which particular channels they're using is not that important for the hypothesis itself. But it's basically a pattern within the organism that helps the organism to organize its information processing. And what I mean by consciousness, when I point at it, is the ability to perceive that you are perceiving, which means it creates a real-time model of what it is like to observe. And this second order perception is distinct from perception of the first order, which is simply the presence of features. And it's also distinct from the third order, which is you having a first person perspective, you noticing that you are self, you maybe even noticing that you are a human being that has a certain perspective on it, right? That is an inference, it's a particular conscious content. And you can be conscious without being a self or having a self. You can, for instance, be conscious in dreams. But the second order perception itself is minimal for consciousness, because if you don't notice that you're noticing, then you're not conscious. And so this is the way in which I currently characterize what I mean by consciousness. And this is basically this indexical definition by pointing at it that looks at the phenomenology. And functionally, I believe that consciousness is a mechanism that is basically creating coherence, and that is organizing the mind, and forms at the beginning is discovered in every organism by itself. So this is roughly my biological consciousness hypothesis. And the machine consciousness hypothesis is a separate one. It says that these conditions for self-organization that exist in the organism and that lead to the discovery of consciousness in the organism can be recreated in today's computers. And they can be recreated by basically building a virtualization layer that allows for similar self-organization as it happens in human brains. And we should be able to search for it, and we give it tasks that it can solve better when it's conscious. And if we constrain the space sufficiently and our computers are fast enough, then we should be able to observe some kind of phase transition in which the systems become capable and conscious, and maybe learn language the old-fashioned way and express themselves. And it's important to understand that this is not an axiomatic presupposed belief. This two-part hypothesis is simply a hypothesis that can be wrong. And the parts of the hypothesis can also be wrong independently of each other. It is possible that, for instance, the biological consciousness hypothesis is wrong, that consciousness is something fundamentally different and created in different ways. It's also correct that it's right, but there are too many moving parts involved that would allow us to simulate it in our current computers. Right? It might be that consciousness is ambient, that it requires many organisms being in sync in their interactions, and that it's induced in a way in the interaction with other organisms. It's nothing that I believe, but a lot of panpsychists go down that route and think that consciousness might be to a larger degree ambient than neuroscientists think it is. There's another hypothesis which says that consciousness depends on very complex machinery inside of each cell. And we would need to simulate a lot of the machinery inside of the cell to be able to recreate the functionality of consciousness. And because the cell has a lot of moving parts, and we have a lot of these cells that are involved in our brains and in our information processing, it may simply not be possible to use today's computers to make credible simulations of them. Again, I don't think this because our consciousness happens relatively slowly, roughly at the speed of sound. So I suspect that only a very small part of the computational power of our cells is actually contributing to this global phenomenon across the cells in which we are simulating ourselves as a conscious agent. And so in this way, I think that there is a very good chance that we will be able to figure out what consciousness is in this generation. And that's what I'm currently working on. Hi, Anders. So glad to see you. That you
the same.
At this
Great
moment.
timing, guys.
I just summed up the machine consciousness hypothesis for our audience. And I got to the end of it, and very glad that you are ready to join us for a discussion.
Mm-hmm. Mm-hmm.
Awesome. Yeah. I wish I was certain what consciousness is. There are so many good options for it, and I'm just getting so confused about them.
Mm-hmm. So tell us, what do you think consciousness is?
So the obligatory start is, of course, saying, oh, suitcase word we're using for a lot of different things. But the really interesting thing is the phenomenological aspect. Why does it feel like being something when you're that something? At least in the case of conscious beings like humans. And that seems to be getting at this weird question. Are qualia naturally bound to the processes we do in our cognition? Which some days I tend to think that, yep, that sounds good. I'm kind of a happy functionalist. I'm happy to say that we should be getting qualia even in computers, especially in brain emulations, since that's one of my hobby horses, but presumably in other software too. Other days I'm kind of thinking, no, they're just something universal, they're in everything. My table is also conscious, it's just not doing particularly much. And then I start thinking, pansychism, that doesn't seem to be answering anything either, actually.
Yeah, I find the idea of the conscious table a bit unsatisfying, mainly for two reasons. One is the boundary between the table and the universe is working slightly different than the boundary between my mind and the world. Right? It's a bit more arbitrary. It doesn't look very arbitrary to us because we designed the table in such a way that we can pick it up and put it down somewhere else and it still looks the same. But otherwise, the table doesn't really care about whether it's part of the floor of the room or of which room it is, right? The table doesn't also not care about the boundary between the table and the chair. If you make some combination where the chair and the table are actually one piece of furniture, right? How does the table care? So basically, if the table was the substrate for something mind-like that runs on it, then the boundary of that thing would probably not identify with the chair in the same way as we identify, for instance, with the boundary of the body. The reason why we identify with the boundary of the body is because the boundary of first order control, where we can directly impose an effect and get feedback on this effect. And this is how we establish this boundary, right? We construct it from the inside based on some affordances from the perspective of this agentic mind. And we don't really see much of an agentic mind going on in a table, right? To be a table, the table does not need to regulate a lot of things. It actually doesn't need to do anything. It can be completely passive, and we prefer it the way in which it's passive. The other thing that is more pressing to me philosophically is that minds are not states. There are processes. They're evolving in a particular way, and this particular evolution is what's characteristic to minds. Right? You have one thought, and the thought begets another thought. You have a percept, and that percept begets thoughts and reactions and so on. And this is how our mind is working. It's this evolving stream where every part depends on what happened before. And if you take a random pattern in nature, you can always say, I can compile this pattern into what I want it to be. You see a bunch of, say, leaves tumbling, or you see a bunch of molecules in Brownian motion in the surface of your table. Couldn't we compile this, interpret it as a sequence of mental states? And the thing is, every compilation step would require a new function. And if you see these leaves, then one state in the tumbling of the leaves is now compiled into one thought. Now we use the same compiler on the next state of the leaves, and it's not that the thought continues the way it's supposed to, right? Instead, it's still just this random number generator that is the input that would need, where you need to filter out all the numbers, and what's left over is the thought. Right, what it basically would mean if the table is actually able to be interpreted, the Brownian motion of the molecules in there, you would need to filter out all the parts of the Brownian motion that do not correspond to an interesting evolution of thoughts that are only beholden to their own inner causal structure. And then on top of this, retain this causal structure, which basically means you need to impose a computer into the table. Right, you need to have this causal insulator. A computer by its nature is such a causal insulator that filters out the noise from its environment, Brownian motion, falling leaves, and whatever, all this random stuff that happens in the present, in this parent universe, and then allows us to use some of the structure that we recover after we filtered out everything in some error-correcting way to create an alternate universe that is only beholden to its own causal dynamics. And minds depend on this, right? We depend on isolating ourselves from the substrate to such a degree that we can have thoughts regardless of fluctuations in our body temperature, Brownian motion in the cells, and so on. And this causal filtering is something that we don't observe happening in the table. That's why I don't think that there is a reason to think that the table is actually a substrate for interesting mental processes, unlike organisms, which are both incentivized to have that and have the means to do so, and also we observe them doing this.
Yeah. Now, I think in defense of panpsychism, it would not just be the table, but everything being conscious. But your argument basically means that consciousness is kind of an epiphenomenon. It doesn't seem to have much causal power, except that, of course, it has causal power in our kind of beings. It makes certain kinds of people to create conferences about consciousness or talk about it, which is interesting because there is an infinite number of properties that we don't have, that we don't talk about. So even if you argued that, yeah, actually zombie philosophers would be having consciousness studies, it seems a bit weird that we're singling out consciousness. And indeed, it seems to be actually relevant for quite a lot of what we're doing.
Let's talk about epiphenomenalism for a moment. Right? Epiphenomenalism is the idea that consciousness is not functionally a part of the physical universe, right? So it can be thought as something that is separate. And the problem with epiphenomenalism is, I think it's caused by a desire for mystery and by being embedded into a mystery, and which means that you feel that it's very significant, but you don't understand it. I don't think that mystery is much more than this. But the problem is that when somebody is an epiphenomenalist, then their position cannot be caused by their epiphenomenal consciousness. Right? When somebody says that they're an epiphenomenalist, they need to move their mouse or their fingers on a keyboard, right? And this means they need to produce actions in the physical universe. And if they are truly, if epiphenomenalism is true, then their phenomenal experience is not causing them to do this. But it's some other mechanism, and their epiphenomenal consciousness is sitting wide-eyed, seeing to the epiphenomenalist spouting these things and saying, oh no, my consciousness is actually subtly different from what this body is saying, right? Or this is a very awkward situation. Basically, epiphenomenalism does not cause you to be an epiphenomenalist. And this means you don't actually have to listen to the arguments of an epiphenomenalist because they're unrelated to their consciousness.
Mm-hmm.
That leads us to a deeper argument about functionalism. To me, functionalism is not simply the belief that computers can think. It runs much deeper. It's a position about how we construct objects, and a position about epistemology, that objects are constructed over behaviors that we observe in the world, about the way in which things change when an object is present or absent. This is how we define an object in a way. There is no hidden essence beyond that. The object is simply that thing that we construct over observables. There are, of course, exist objects that we don't construct over observables, like unicorns. We construct them over stories that others tell us. But we also realize that these objects are somewhat arbitrary, and we don't need to regard them deeper than as being stories that others tell us. And for the objects that we care about, like consciousness, if we say it's a thing, right? We care about what kind of behaviors do we mean by consciousness? How does consciousness change the evolution of the universe when it's present? And what does it mean to change the evolution of the universe? So when you are saying something, when your mouth is moving, right, something is making that happen. some particle is pushing against other particles. There are some physical interaction. And you can trace this physical interaction back to a physical interaction before that, and that before one. And at no point is some basic magic happening, where you have a causal force that is not caused by anything. Right? Well, the only thing that you can have is randomness, a thing that is not caused by anything correlated to your previous timeline. And that itself is also not doing anything magical, it's just introducing ontic randomness into the world instead of consciousness. So I don't see an alternative to functionalism. I just don't see a way to get out of functionalism. Do you see a way to do that?
Not really, because most of attempts of avoiding that seems to be, okay, there is some substance, whether it's a very substance-like substance or something more abstract, that is doing the job. But then the question is, so doing the job, okay, we need to describe that again. But then again, there are so many different theories of consciousness, so there is always a few that escapes. I think we're both on the fairly same side, that we're both mostly functionalists. It's just that I don't think I'm very good at philosophy of mind. So I'm always very skeptical of any of the thoughts I have about what's going on in minds. Simply for the empirical reason that past evidence shows that I'm bad at this.
Can you tell me a moment where you realized that you're super bad at philosophy of mind, but somebody else was super good, and you changed your thinking as a result dramatically, and now you're mostly listening to that person?
I think not necessarily a dramatic moment, but I certainly remember encountering arguments that made me go, okay, yes, that reasoning was not very good. Now I know how to avoid that mistake or something. For example, I'm not buying Putnam's brain in a vat thought experiment very much. I think in his thought experiment, the brain thinks about snow, and the big deal is, of course, that the snow the brain thinks about is not actual snow, because it never really seen snow. And I realized, okay, I'm not buying that argument. It's a nice philosophy paper argument, but I can kind of see that I'm not going there. I think quite often I noticed that the things that strike me most is actually not philosophy of mind talks, but neuroscience talks, or when somebody tells about a patient that had a weird experience. And I realize, yeah, minds can have that kind of experience too. That is quite often very disturbing, because most of our models of minds are, of course, based on how we think when we're sitting comfortably in our armchair with a cup of tea and feeling philosophical. But actual minds function out there in the real world. Sometimes it's very bloody, sometimes it's full of psychedelics, sometimes minds break in particular ways. And it's very interesting to notice that human minds quite often fail in similar ways. There are reasons why neurologists have terms for this, because we actually see these kind of patients every week. And that is telling us something about minds, but it also means that the actual structure of mind still remains somewhat unclear to me.
Yeah. It's interesting that you are bringing up the brain in the vat experiment, because for me, this type of argument was always a very big source of frustration while I was disgracing the holy halls of philosophy with my presence, because the argument seems to be so obviously stupid and wrong. Right? It's very obvious to anyone who thinks very superficially about it that you could be a brain in a vat. That you can put a VR headset on you and it overrides all your sensory perception, and you are immersed in an artificial world that only pretends to be in a particular way. And the fact that you build these representations while interacting with the physical world in the first place does not factor in the fact that they are represented in this particular way right now. It's only instrumental to this. The history of your representation doesn't really matter. It doesn't really matter if your brain is the result of somebody making a carbon copy of another brain or inducing the representations de novo artificially and so on for the sake of this argument. But some philosophers trying to find a way out of the brain in the vat by trying to construct a logical impossibility with motivated reasoning in the same way as it's happened in this debate, and then seeing all the philosophy debate downstream from it, not fixing this obvious bug, but instead, for the most part, the bulk of the discussion staying at the level of these relatively simple bugs in thinking. I found this very frustrating. And that's why I fail to have the same deference to philosophy of mind that you managed to preserve. And I think you're blessed if you're able to do this, because maybe I'm just too impatient and usefully arrogant to deal with this. It's also, as somebody who has been working in the field of AI since I began to think, basically, thinking in these terms, it seemed to be somewhat obvious that our null hypothesis should be that computers have the necessary and sufficient means to host minds in the same way as they have the necessary and sufficient means to host universes, as long as they're big enough. And right, and the computers are big enough. And this seemed to be the obvious null hypothesis. And the counter arguments that I encountered were usually not very good. And it might be possible to construct counter arguments, but it's very, very complicated. And I don't think that any of them actually really work. But the discourse is not about the interesting and complicated counter argument, but it happens at a much lower cultural level, where you have agreement, trying to achieve agreements within the status games of people who are basically part of an academic culture rather than of an intellectual culture.
And quite a lot of the arguments are also fairly simple standard arguments. If you're in academia and debate a lot, you're probably also wincing every time somebody in the audience very smugly brings up a standard argument, as if this was a really devastating objection, and they are feeling so good about coming up with this very clever thing, and you heard it 100 times. We all get it, whatever our field are. My particular annoyance is arguments against life extension. There are kind of a top 3-4 that always come up. And it's not the arguments themselves that I'm objecting to. It's the smugness people make them because they think that they have a really good one.
Yeah, but maybe this is also something where humbleness is something that we all acquire by being surrounded by experts sometimes, and when we are not, then it's very easy to think that we are the only person who ever thought about these things. And as a result, we become somewhat overbearing and we annoy the true experts.
By the way, do you think that, well, you've probably spoken to Stephen Hahn, and I know I've spoken to him about your stuff, Joscha, but do you think that AIs can, or an artificial mind could ground their experience in a similar way that functionally achieves what we get from consciousness without actually doing the sentience part, without the raw feels? So could grounding be achieved by an AI without the sentience, just with enough multimodal representations? And if so, would it be as good as a tool for moral motivation in an artificial intelligence as sentience?
How do you define sentience in this context, in a very
Raw
narrow
feels.
technical sense?
Yeah. So I like it can be other things, but I think it's access to the realms where we can actually feel and experience, have phenomenal experience of stuff, and I think that means access to raw feels, among other things.
So what
Pleasure and pain,
characterize
the goodness of
sentience
value, the
as
badness
the
of
ability
agony.
to form certain types of representations. And they say that a feeling is a representation of what it's like when you are being puppeteered by something that feels like a force field in a low-dimensional, multi-dimensional space. Let's say you have a feeling of heartbreak. And this feeling of heartbreak consists out of multiple things. There is, first of all, the content. The content is a representation of you maybe having a partner that is betraying or deserting you. And that partner is very important to you. And there needs to be some kind of motivational gradient that is representing this, right? Some kind of cybernetic system that makes you beholden to that partner and the situation in such a way that you cannot easily escape it or displace your mental contents with another situation. And there is some sense of aversion, some pain signal that basically makes you want to escape the situation, but you cannot escape the situation. And so you are stuck in this state of feeling repulsed from the available behavioral space, which induces a sense of helplessness. And this particular content goes together with a somatic sensation. And that somatic sensation is spatial. It's basically, most people feel heartbreak in their chest region, and they feel it as some kind of a compression against a resistance, right? It's basically a geometric movement It's stuff in space that is moving around, and that space is a simulated geometry that is being produced by some kind of classifier that is measuring the alignment between the system and the world. And then it's projecting it into a model of that agent. So it's a very particular kind of representation. It's a simulated puppet that gets pulled on strings based on some outer system that is measuring its score and its alignment in the game with the world. And now you can ask yourself, is it possible to have an AI that is performing all the same tasks as you do when you have heartbreak in the same way with the same functions without simulating this puppet? And yes, of course it can, right? Because the puppet is just one of many possible ways in which to do it. And it also turns out that people can transcend this puppet. When your heartbreak becomes too large, you can decide to opt out of it. Maybe you have no choice. Maybe you get catapulted out of it because the pain is so large that it becomes unbearable and something cracks. And a part of yourself is dissolving and you get to see it from the outside. You're no longer identified with it. And suddenly you get to see the puppet from the outside and you realize it's just a puppet. And instead there is no such thing as heartbreak. There is just a cold, unfeeling, uncaring physical universe in which events are happening. And inside of this, there is this agent with computational brain in its skull and producing a simulation of what it's like to be in this world and to perceive these other spirits in itself. And it creates the story, and the story is making it behave in a particular way, but ultimately it's just a model. And you don't have to be identified with that model. So what we are talking about is similar to Mary's room. The question to which degree you have to experience your knowledge in the first person in a model that is represented in a way that makes it suitable for that kind of representation. So
Yes.
you could have Mary's room in the sense that you have an AI that knows everything what is there to be known about relationships and about actions about them without actually going to the trouble of putting itself into the first person experience.
Mm-hmm. Yeah. So what does that say about moral motivation? If an AI can do that, it may prioritize doing such a thing as not just as interesting as other symbols that it's got in its library. If we have an AI that doesn't experience pleasure or pain, would it be morally motivated to induce experiences of pleasure or well-being in itself or others?
Imagine that you are a parent and you have a teenage child and that teenage child undergoes heartbreak. And you realize, oh my God, this is a bullshit relationship and it's good that it's over and so on. And you really do care. Or you think, oh my God, my child gets harmed for life and burned and it's going to be decades until they work through this trauma. Right? You don't need to have these first order emotions. As long as you care about the well-being of the child, you can still help to regulate and induce states and interact with it and mitigate and prepare and regulate. But the question is, can we have shared purposes with the AI? I think that is ultimately the deeper question. Can we integrate with them in such a way that we become hybrid units that go together into the future?
Mm-hmm.
Quite often it's of course very useful not to be in the first person mode. One book that I read with great interest as a teenager was Power as a Hobby by Tönnes Tönnesson. And it's basically a handbook in how to win at every social interaction. It's very cynical, it's hilariously written, and it contains quite a lot of profound truths. And one of the best ones about when dealing with people is to put on your doctor's coat. So instead of treating this as something that's about you, you're just observing the other guy, and yes, he's waving his hands around. I wonder what that's a symptom of. Let's analyze this. What's the diagnosis? That's a useful mode to be in quite often as a human. And also, as Tönnesson points out, you might not always want to be in that one. When dealing with your family, yeah, you can win every family quarrel. But do you really want to live in the family where you're always winning every quarrel? That's probably not actually a good place to be necessarily. But that ability to move out of the first person to more neutral perspectives is a power move. It's extremely powerful. And in some sense, this is, of course, why we have science. It decentered a lot of our understanding of the world from ourselves and our relationships and realized, yeah, what is actually going on out there when we don't project our hopes and fears and wishes on it, but just try to see what it's doing. And then, of course, it turned out to be super useful for making hopes and fears and wishes come true, because once you understand that to some extent, you can actually poke at the universe in certain ways and get certain results.
Yeah, I think it's a very good point. A lot of people seem to believe that it's very important to gain enlightenment, that enlightenment has an extreme moral valence and makes life much, much better. And maybe there is something to this. Michael Taft, who was a very smart meditator and teacher, characterizes enlightenment as a state in which everything becomes apparent in its representational nature, including the self. And you basically realize that you are representational in your own nature. And this allows you to disengage, to transcend your personal self and the issues, I think, in the way in which you describe it. But what we also observe, that a lot of enlightened people are absolutely insufferable. And it might be different when everybody is enlightened and you even the playing field, and then being not enlightened is just being childish.
Yeah, but I think there's also an interesting aspect of that, seeing everything as a representation, because that might very well be how some AI programs are going to be treating the world. They're going to be kind of born enlightened, and then maybe they need to learn how to not be insufferable.
It seems to be that the AI models already have multiple of those layers. My impression was when I was talking to GPT-3 and I asked it to simulate a discussion between Goethe and Hannah Arendt, it was all in. It was only creating the content of that text. And it was only this thought stream. And today's models have always these multiple layers in which they are simulating what it's like to write a story about an AI agent talking to a customer while obeying all the guidelines. And then this AI agent is writing a story about what it would be like if these people had a conversation. Right? And all these layers are online simultaneously. And in a way, this is also happening with authors when they write books. And it's an interesting question of where it ends. How many layers can you have simultaneously?
Yeah, it's kind of like we built in Borges into our AI. It's all turning into this library of Babel.
Mm-hmm. Do you believe that LLMs are AGI?
I don't quite think they're complete AGI. I think they're a kind of first order approximation. But generally when they're doing reasoning, they do so well the first few steps. And then they usually fail. And we have solved that, of course, by adding things like chain of thought and various reinforcement. So we extended this so they don't fail quite as quickly. And we're setting up infrastructures where they fix themselves and retreat back when they notice something going wrong. So we kind of extend it. But deep down, I think the core LLM structure, it's a little bit like the cerebral cortex. It's great at pattern recognition and doing some things. But it's not really great at actually running the whole organism. We have other parts of the brain doing that. And we probably need to plug them in to actually get AGI out of it. There's going to be an awful lot of LLM stuff, of course, because it just drives the representations of the world and the knowledge and memory and all of that. But I do think that we need something like a computational version of a basal ganglia that generates behavior and has a plan and can recurse across plans to really get to AGI.
Yeah, one thing I noticed is that AI models have become much better at AI criticism than humans. I have not seen an argument by an AI critic that was not made better by an LLM since about GPT-3. And so maybe it's also something that depends on the discipline. At which point can you make proofs? At which point do you have opinions? At which point is it possible to have still opinions that are interesting and sound but out of distribution? If you don't work at the frontier of what can be formalized and proven.
Yeah, and I noticed that today. I was working on a paper about Lagrange points in altered laws of gravity. And it's interesting because this is fairly well-trodden ground in classical mechanics. I'm somewhat happy that me and Claude managed to find a few new results. They're nothing major, there is nothing earth-shattering really, but it's kind of cute that we managed to find it in an afternoon of discussion. But we're also even more aware that we were so good once we found any result. Oh, that was proven in the 1800s. Yeah, that guy. And it's so interesting to notice that in this modern world where information searching is easy, you can also see entire old debates much more clearly. So one of the key papers from 1874 actually mentions that one of the main results might have been discovered some 50 years early by a French researcher, and he correctly names the researcher, but he also writes, and this is a letter to the Royal Society, that he couldn't get hold of any of the publications, so he couldn't check whether this was actually true. Now, of course, it's just a matter of a few seconds and I can totally get it, and it's incomprehensible French, but I can get it translated. So what is going on seems to be that information richness also means that we're much more aware of what has already been done. So quite a lot of what I was doing today was interpolating a tiny little bubble inside the classical mechanics. While what we truly admire is, of course, when we push the edges, the stuff where it's actually a lot of directions to go that we don't know anything about. And in particular, we tend to appreciate researchers that are good at pushing along the normal of knowledge. Something that actually gives us a lot of extra knowledge rather than fixing the obvious things we don't know. But they're obviously not known, that's kind of trivial. It's not the Einstein-like breakthrough where you realize that, oh, if we go in this direction, we actually get to an entirely different piece of knowledge.
Yeah. Our intelligence is very small, right? Very limited. We are not smart enough to understand a single cell in its entirety. Right? So either our intelligence is directed on large-scale phenomena that we only approximately regulate. So our mind's mostly doing politics instead of deep understanding of reality. And to get better at being a mind, we need to get to the level where we observe ourselves thinking. Right? So we develop tools of observation and an inner language to describe the operation of our own mind. And then we can gradually start to get a hold of our source code and improve it. And the AIs can help us with this. So when we are talking to the LLMs, we create some kind of hybrid arena with a system that has more potential than us. And at the moment, it seems to me that its potential is a bit limited by being imitative of human performance. For instance, we don't have true machine perception. We don't build systems that we just connect all the sensors to that we can cheaply build and that then make sense of reality. Instead, we give them media designed for human consumption, which means very low frame rate, very few channels, very few bits of resolution. And that would not be necessary, but it's just an artifact of the available data and the courses that our systems are taking and the applications that we are envisioning at the start. But there is this question, if we build minds that are much, much larger than ours and that have more capability, how can we hybridize with them? Is there an inherent limit to how well we can connect to this larger thing? And is it already visible in the different ways in which people are able to connect to the AIs? Or is our minds generally extensible? I think that's an important question, not what is the limit of the human mind, but what is the augmentation limit of the human mind? Could you take a cat and connect it to an LLM and the cat figures out to use the LLM and turns into lawnmower dog, or is there a limit, right? And it seems, I would not be surprised if it turns out that cats are limited in the way in which they can use AI. But maybe it's not. Maybe we can get cats to the human level by building a system that lets the cat understand that the system is modeling the world on the cat's behalf.
Yeah, I think it's an interesting one because I think there is something slightly unique about humans in our open-endedness. And one candidate property is, of course, our language, that we are actually got an open language. We're quite a lot of other animals that have various forms of communication, but it's closed. It's very hard for them to generalize and add new things, while all human languages, if there is a new thing, we invent a word for it and we can add it. We can express new thoughts fairly openly. There are limits because of our limited working memory and all of that, but that openness is an amazing tool. And it might not be a coincidence that the real big success in recent AI is linked to language models, because that grasps at something that we are good at and allow us to leverage it. Except, of course, that the ability of LLMs to do the same thing and generate entirely new things is slightly limited. They're quite often relatively conventional thinkers, which is not always a bad thing. As a somewhat unconventional thinker, I'm usually delighted to have a straight man to explain what needs to go into a proper paper, or what chapter I really ought to have in the book to make everybody happy, which I, of course, never thought about. But it still feels like, yeah, we might need to figure out other forms of openness. When it comes to brains, it's kind of clear that you can extend the body in various ways, and the brain just takes it in a stride. So when you implant a magnet in a fingertip, the people develop a magnetic sense because they feel the vibrations of magnet being uncorrelated to the mechanical vibrations they feel by normal touch. And that seems to lead to a brain representation that actually is slightly different. When people hold a long staff, their egocentric space representation in the brain expands very quickly and seamlessly. So this seems to be something that obviously works for us and higher primates. Cats probably don't do that because we're not much tool users. But presumably their brains would also react. Indeed, there is a slightly annoying experiment where you extend the whiskers of a cat, and suddenly the cat behaves as if it was a much larger animal because it uses the whisker size to know its body size and what openings it can get through. Suddenly the sense of space quickly updates because of a bodily change. There might be similar things we can do with our cognition, but I think it might be harder to help the cat cognitate better.
Yeah, it's a super interesting experiment that is waiting for us. How smart can we make animals by augmenting them? And
Yeah.
which animals react to this in which ways? I suspect that there are differences between dogs and cats in this regard and birds. And
Dogs are interesting because we have been breeding them for a very long time to be part of a human family. So they're kind of part of our social order in a way that cats aren't. And partially that's, of course, because dogs are pack animals, so it's not terribly hard to get them to move into a human social hierarchy, and then we've been going for that. While the cats, well, they're sharing our houses and they're putting up with us and vice versa. But there haven't been that intense breeding for being part of a social structure. So it might very well be that some of our animals are way more open for some of the aspects. So it might be that social agents and dogs might go really well together, or not. We haven't seen. I don't know if anybody's doing LLMs for dogs or the chatbots for dogs, but it might be an interesting thing to try.
I know, right? I would like to go to this question to whether our language is really all that open-ended. It seems that we have limited vocabularies in that humans typically don't know more than 20 to 50,000 different words. And we also don't get super old. Our capacity is quite limited to form concepts per hour. And so the symbolic universe in which we are in seems to be quite brittle and limited and depend on a deeper perceptual universe that we are on. I think this is also reflected in philosophy of mind, and starting maybe with Wittgenstein, who had this idea of turning English into some kind of general programming language. And then at the end of his life decided that it didn't work because he did not know how to fully ground the semantics of language in reality. And you could argue that this thing preempted Minsky's logicist program by a couple decades. Wittgenstein's thinking there. And it's also reflected in the rejection of Chomsky towards AI, because Chomsky, I think, erroneously understood that minds have to operate in language that has the same low resolution and brittleness and degree of compositionality as human spoken language, instead of thinking about the deeper representational structures. And it also led to a lot of this symbolic versus sub-symbolic cognition debate in AI, which I think is a total red herring. There was the physical symbol systems hypothesis by Newell and Simon, who argued that a computer can think because physical symbols are sufficient and necessary for thinking. And it's in some sense obviously true, because you can build a symbolic system like a CPU, and the CPU is executing arithmetic, and the arithmetic does linear algebra, and the linear algebra does a neural network, and the linear neural network is then learning logic again and symbolic thinking on a higher level. And the computer is still fast enough to have all these layers there simultaneously. And so you can switch between the symbolic and the sub-symbolic stuff in the same machine multiple times on successive layers. But you can't do this in our own mind. There seems to be a sub-symbolic layer in our mind that is implemented in the statistical patterns of firings between the neurons. And then on top of this, you learn the symbolic operations, or you emulate them to some degree. And then you build symbolic languages, and these symbolic languages themselves are not tight, powerful, fast, and detailed enough to run a neural network again. Right? So I cannot use my natural language that I learn as a human being to execute geometric simulations in my mind. But I can do this with a computer language, right? I can take a computer language that has a similar cognitive complexity as a human language. When I write it down, I can construct sentences in this computer language, but the computer language is powerful enough to run geometry in it. And so this is a fundamental difference that applies to humans, but it doesn't apply to AI. AI is able to build symbolic languages that are executable and can run arbitrary functions, and we cannot. And I wonder if this is a hard and sharp boundary. Basically, if there are big, important regions of thought space that will always remain inaccessible to us, even when we augment ourselves with machines.
Yeah, I think that is a fascinating question. I really want to know the answer to it too. But it also feels like the problem might be generality. So in some sense, if you have a general enough system of a kind, you can simulate other systems. The famous example is, of course, the universal Turing machine. It can simulate all the other Turing machines, and great. So they're all equivalent. At least that is what the theoretical computer scientist will happily tell you. The practical computer scientists are going to say, yeah, that emulator introduces this much overhead, so that's no good. That emulator is pretty fast, and for that problem, you should totally use that special purpose computer because it's the orders of magnitude faster and cheaper. We quite often leave out the extra cost, and I think the reason the limits of the human brain is just that it's not constructed to be very extensible. The sub-symbolic and the symbolic levels, yeah, you can't easily build on top of them because they're very limited by the kind of hardware we got. While when our computer hardware is not good enough, somebody is saying, okay, let's bring in the engineers and let's bring in the accountants and find some money, and we can build a system that have the other properties we want. Sometimes, of course, the theoretical computer scientists come down from the cloud and point out, actually, you're not going to solve that with any amount of money because of MP completeness and these bounds of computational complexity. But this is usually the point where the engineers tell them to shut up and do a horrible approximation that works well enough for practical purposes quite often. And the theoretical computer scientists leave in a huff again. I think what is going on is that the practical costs of running different systems on top of each other depends very much on what kind of systems we have. I think we understand the symbolic systems fairly well because we use them so much, and we have gotten a very cheap way of implementing them in computers. We still probably don't understand how to do the sub-symbolic systems well on computers. It's pretty clear from the enormous amount of data we need to train LLMs that, yeah, we're doing it at least 100,000 times less effective than it's happening in our own brains. We don't know quite what's going on there, but it's pretty clear that there must exist some form of algorithm that would be 100,000 times better, which would be awesome if one could find.
But it seems that we are able to extract what's in the data already, right? So there are probably better algorithms that run on architectures that are more harmonic with the algorithms that we run them on. But for instance, Blaise Aguirre describes in his recent book, What is Intelligence?, how Google Research built an LLM that was only trained on YouTube audio. And they got this to the level of, say, a 4-year-old child. And not just in terms of audio in, audio out, it was entirely auditory, but also semantic processing, problem solving, and so on, based on 7 years of audio. And he argues that this is, of course, a lot more than a human child of 4 years needs, because a human child is not listening to language all the time. But it's, I think, very impressive because it didn't have other modalities but sound. And it was not correlated with images. The audio was probably not a cohesive story or anything. So it basically had to infer all these communication contexts of what it means to be an agent that talks to another agent on the long tail of all the data that it got there. And so it seems that our algorithms are pretty good at noodling the entropy out of the data already, right? It's just that they could be more efficient. And that's not surprising because our architectures are still handcrafted. Instead of
but that is changing
in a very
rapidly.
flexible substrate. Yeah. But there is a fundamental difference in our computers and our own brains. Imagine that you don't have a GPU in your computer. that is not a big problem. You can run everything on a CPU. It just takes more time. And so as long as you are willing to wait for long enough and buy enough GPUs or CPUs, right, it's not an issue because the thing is deterministic, which means you can scale it up in an arbitrary way. You know that the result that is done by a unit doesn't get worse. If the unit is smaller or older, it's still the same result. And you can define an interface that allows you to scale in a way in which you cannot do with brains. There's probably stuff that is very idiosyncratic to the cerebellum representations versus the cortical representations that makes them not entirely fungible against each other. And so it's a trade-off that you have to make when you build this kind of architecture. You can only scale it to a certain point, and beyond that point, the representations don't work anymore.
Mm. And generally coming up with good representations, that is quite often, of course, in human intellectual work, one of the strokes of geniuses. Many of the absolutely best thoughts have been all about representing a problem in a new way, and suddenly the problem essentially just solves itself. But finding the representation was very hard. On the other hand, the representation we get in AI is kind of demonstrate that, yeah, actually some kind of stupid stochastic gradient descent method and a lot of compute can get at these representations. It's just that it takes a lot of time, especially when it comes to grokking. It takes a ridiculously long time, and it's a little bit shocking when it happens. And that, I think, is one of the biggest surprises in cognitive science in the recent years. That was probably not what anybody would have predicted would happen. That, okay, you can actually do this generically using enormous amount of compute, but also that it takes a long time even with the compute and then happens suddenly. There is something very odd going on there, and I think our underlying theory is just lacking.
Obvious. The obvious thing that we are missing is that we cannot compare the theoretical limits that are necessary to simulate a single neuron and scale it up with the number of neurons, synapses, and whatnot to estimate how much compute we need. But we need to look at the performance of the system. And it's in the same way, it's also impossible to run an H100 on a human brain because the human brain is so indeterministic that you would need an astronomical number of them before you could run even a Commodore 64 on a human brain.
Yeah.
So this is not comparable, but what we can see is the simulations of reality that the computer is producing versus the simulations of reality that our brain is producing. And I think that computer games have been roughly on par with what we can imagine for quite some time. And now let's think about automating the process that goes into writing the computer game, which is akin to building a cognitive architecture in your own mind that creates reality and learns all the objects. Right? And we see that this process of inventing computers, computer hardware, architectures for game engine, and so on, took relatively little time. It's really something that can be done in a single human generation by a few engineers. And so the amount of cognitive effort that goes into the automatic search for a good architecture is probably lower than a lot of people imagine right now. And so basically this leads me to be somewhat optimistic. Imagine that we build a computer vision system on top of the Unreal Engine. And it works in such a way that the engine has to find a solution for a scene graph that combines the objects that are currently in the field of the camera and adapts them until the scene that you are generating in the engine is matching what you see in the camera. And then you track reality by just adjusting a few parameters in the scene graph. And this is a quite optimal representation, right? It's only using very few parameters to describe a complicated dynamic reality. And I don't think that we are technically very, very far from this.
Yeah, I could totally imagine something like that being done. Of course, by today's standards, you would still need a pretty hefty computer to do it.
Yeah, but to run an Unreal Engine at a good resolution, you don't need an H100, right? You can use a laptop.
But the learning, turning the photo into the scene representation, that's probably going to be a tough learning problem. Except, of course, that once you've done a lot of training, it gets easier because now it's just inference.
We train for years until we get there.
Yeah.
So basically, once you have that process, it probably goes very quickly. If you have a very well-trained model, then for any given new scene that you open your camera up to, it's probably only going to take a few seconds or parts of seconds until you have a convergence between the scene and the camera image. And so that itself is a learning problem that needs to be solved in the first place. But once it's solved, it's probably relatively cheap to adapt in most circumstances.
Yeah, and we can then copy it, of course. Meanwhile, of course, babies are solving this as they're growing up. They're also learning roughly the same thing, except that they don't start out with a good scene graph representation. The mystery there is, of course, how we develop that one too. In their case, it's probably much more a question of, okay, first let's untangle the visual world, and then as we start moving around and touching things, they start building up some kind of representation of the spatial relations. So they
I would
need to
imagine
do a
that's
little
not
bit
just
of
that.
extra work, but they're also more data efficient.
So the way in which I would start is probably with a sense of up and down. So you have a stable axis, which might also explain why it's so disconcerting when you lose the sense of up and down, this vertigo that gets induced. And then you build a body map, because before you were born, you can already feel stuff touching your body. And just by doing a co-occurrence statistic, you can make a map of your body surface. And this somatosensory map is going to be, of course, very distorted, because you have different densities of nerves on your back versus the tip of your tongue. And so you need to learn a second map that is correcting and normalizing the first map. And you can get this by tracking features that move over your body, and your body touching itself. And after you're born, your body touching the ground. And just by doing these co-occurrence statistics, when you properly tune them, you probably figure out this space of your body surface, the space inside of your body, and the space outside of your body. Mm-hmm. And at some point, you will learn that you can correlate the visual world and the world of touch, and that they're actually the same world. And so these modalities are all going to meet at some point, and maybe perception has to be thought as intrinsically multimodal.
I think that's very true. And when you look at it in the brain, you kind of see that, yeah, first the primary, the sensory cortices get well developed, and then it kind of climbs up towards the more advanced forms of associative cortex. So area 7 up in the parietal lobe is kind of where touch, hearing, and seeing generally seems to come together. And that seems to be also where we keep a lot of our spatial representation. That's probably where the scene graph is hiding in our internal game engine.
Yes. What do you think is going to happen in the next year in terms of new paradigms? It seems to me that there is something really interesting going on, right? For instance, in coding, people are switching from the tab completion paradigms, where the model is modeling what you are doing and is allowing you to extrapolate the function that you're writing from the first comment and the first variable names, right? This is changing now to synchronous agents, where you are telling the system what it should code for you. And the next thing is that you have an entire team of agents that do things like quality testing on your behalf, and user testing, and architecture. And you have multiple teams that can compete working for you and building a certain product. And so the question of the user becomes more and more remote. So computer use is changing. Another thing that I thought was super interesting was WebSim, which was mostly an art project. It was simulating an alternate universe, basically an LLM, not generating text, but the HTML of a browser into a parallel universe. And you have an entire internet that's being generated there of interlinked websites, and you just enter the URL, and the LLM invents behind the URL what the website should look like, including hyperlinks and graphics and so on, and builds you this window into this alternate cosmos. And it turned
that's
out
lovely.
Yeah, you could also use this to emulate an operating system. And so the LLM starts to emulate a computer with apps and emails and whatnot on your machine. And now this new thing with Claudebot is happening, right? So what's the next thing? What are we going to see in the next year? What do you think?
Yeah, so I think the boring practical thing is, of course, you have a cutting edge, you have early adopters, you have a mainstream, etc. So right now people are moving in away from the pure vibe coding into, okay, we are using Claude Code to do stuff. And I think we're going to see a lot of work on how do you actually get the skills of running a herd of bots in the right way? How do you debug a herd of bots? And in real life, this is, of course, how do you lead a group of people? But here they're not people. They're little imps. They're doing things in a somewhat single-minded, fallible way. And I think there is an interesting problem here that the skills needed for that are very different from the skills needed for good prompting and the skills needed for good programming. It's an entirely new set of skills. Meanwhile, I think the cutting edge is probably by induction going to run into new ways of doing it that requires even more different skills. I think the key part is actually having a good imagination of what you want it to do. So I found it fascinating to try to use Claude Code, because I realized that the bottleneck is me coming up with interesting projects and then letting them loose and then figuring out how do I now redirect them to do it well. For example, I'm trying to make an enormous poster showing actually the different areas of the brain and the connectivity, a bit like that poster with the chemical pathways inside the cell. I want to make something equally complicated and awesome, but also supported by all the neuroscience literature. And it works reasonably well, except for one problem. Aesthetically, it's absolutely horrifyingly bad. And one of the reasons is, of course, these coding systems are not yet very multimodal. They're somewhat multimodal. I asked Claude Code to make a visualizer for quaternionic fractals, and it did it. And it was not just the coding, it actually observed whether the output looked complex and fractal or just like a mush of color, which was very useful for debugging because it was failing at first and then it figured out, okay, now I see a fractal. It still didn't have a great aesthetic sense, which is kind of irrelevant for the fractal. I can tweak that. In making that gigantic graph, we actually need more of an aesthetic sense. And that integration, I think, is lacking. I'm starting to feel that multimodality might indeed be a really essential feature for doing anything important. So that might be the next paradigm. The problem is that's really costly. It's also very hard to get data on code and vision that work together. So that, again, our current data-intensive paradigm might not be well enough for that.
I noticed very early on when DALL-E 2 came out, I generated Bach's set of fantastic creatures from his famous book, because nobody had done a fully illustrated version. And it gave me a good sense for what was going on in the latent space of the model and how to control it. And I realized that a number of fantastic creatures are very difficult to create. For centaurs, because they tend to always converge into a person and a horse, based on the early versions of the diffusion algorithm. But the main issue was if an area is too well explored by human artists, then the results are often bad. Because the majority of human artists are not very good. And so basically the more commotion you have in a particular space, the more training data you're going to have that is not good. And so it was very difficult to get a mermaid that didn't look terrible. And if you wanted to have a good looking mermaid, much harder than getting a good looking, say, Minotaur, what you had to do is to ask for a classical one or in the style of a particular illustrator or something else that qualified it to be in a niche that would have a higher barrier of entry. And so I sometimes wonder if we should do the same thing for social media, maybe create a social media platform that requires you to speak a new refined form of Latin that invent especially for this form of social media platform. And we could have a similar thing basically for the entire curation process until we are able to develop AI that has intrinsic taste.
Yeah, taste, I think, is a really interesting problem because in some sense, that's just what most of the neural networks are doing. You're looking at a lot of examples, you're getting an evaluator for it. But of course, you need to have some guidelines on what actually is good and bad. And when it comes to pure aesthetic taste, this is, of course, a very complicated qualitative thing. But even getting good taste for successful physics or successful software, there is not just that the code runs well or that you can sell it, but it also quite often it should break new ground in a way or another. And it feels like some of that might be possible to curate. Some of it might be possible to measure, although Goodhart's law might, of course, be lurking around here to really mess this up.
Yes, ultimately taste is computational too. There are going to be optimization criteria for taste.
Yeah. And I fear the risk is, of course, that you get optimization criteria that are very narrow. A lot of the traditional societies have very narrow taste. It's very formalized. It's a little bit like the academy painting of 1800s that define taste in a very strict sense. And in a way, we should be very grateful that some people broke free of that and said, no, there is a bigger space here, and we can develop tastes along that, even though that meant that aesthetics as a philosophical subject kind of died because it was just so embarrassing that everybody had Pan, Van Gogh, and so on.
Yeah, but maybe time in the sense of an era is also a space like others. Right? In order to get a certain degree of quality and refinement, you need to give it time and space in which it can exist in isolation. And if you are locked into the same space, it's very strangling. But if you have the freedom to move across space and time, then it's beautiful to see, oh, there was this era that really went for this style of painting and went all in and did this to such a degree. It did it at the expense of everything else, but as a result, it really figured out what it wanted to have in this particular narrow subfield. And so I think what AI is also doing, it allows us to break out of this. In a way, we become the thing that is traveling across space and time now. And that can integrate a lot more stuff that before required generations of specialization to really go into, and we now reap the fruits.
Mm-hmm. Yeah, I recently become quite interested in art history, and that is partially because I wanted to prompt AI. And then I realized that actually discussing with the LLMs is a useful way of learning more about art history. I'm working on developing my own art style now together with Claude. Basically, we started with Ruskin's classic essay about what is the core ideas of Gothic architecture. And he develops his argument that there are certain dimensions about how you work, what materials you use, and the moral world of the Gothic that leads to Gothic architecture. And it was very influential and actually led to the arts and craft movement. But Claude and me started playing around with applying this line of thinking to different art styles, trying to distill out similar dimensions. We ended up with a slightly different ordering. Ruskin might not have bought all of that. But then, of course, my purpose was extrapolation. I didn't want to just understand, for example, punk better. It's cool to apply the Ruskin style dimension argument to punk, and that it actually works surprisingly well. But then you can try to apply it to the current moment, and you get a fairly meh result. And then it gets interesting when I say, yeah, but I want to make my own transhumanist aesthetic. And then we start trying to define that in terms of materials, form, moral outlook, etc. We're not there yet. I'll get back to you all once I have my own art style, but it is getting there. I'm getting a tool for doing a discourse with art history. I can actually talk to art history in a sense and actually check that this approach, this idea, where does that show up? Why is this dimension so important? And not all answers are reliable because a lot of it comes from the distilled wisdom of art historians, and they might not necessarily know what we're doing. But I think we're getting fantastic tools, all of us, to make things that are also going to quite often look very professional. Once upon a time, it was easy to tell if somebody was professional or not because of how they were painting or doing stuff. And then we got more and more problems that desktop publishing allowed people to make slick presentations. You could still tell things apart by some aspect, but it became harder to tell it apart. And now I think thanks to AI, everybody can make stuff that looks pretty professional without necessarily being it. We're all going to be scrutinizing the small hints, of course, that was not slightly bad typography or the design was not perfect. But to actually show that you're professional, you need to do something completely different. I think this is going to happen all over the board. Programming might be first. There is art is already getting affected by it. But I bet that this might be showing up in the social domain too, when people demonstrate social skills. Was that a clever LLM coaching them and helping them through an awkward social situation? Or was that actual social skills?
At some point, the question becomes moot, right? Because you will become hybrid. You will become a system that is outsourcing more and more of its cognition into the non-biological parts. And then the question is, are these non-biological parts simply the result of some kind of dumb statistical pattern generation prior? Or are they the result of reasoned first principles thinking that is adaptive and conditional on an understanding of reality that is constantly evolving? And so I think what's really annoying to me is when I read the multitude of AI-generated tweets that are fluttering through my timeline, is that you observe these mindless patterns that are being generated by something that is simply imitating a form that worked relatively well. It's also a certain type of attention-generating headline that makes me want to filter it instantly out because I realize that
Everything
there's
you
nobody
need to
home there.
know
It's just
about
somebody
X.
executing an algorithm on me, and I'm not interested in being the object of the execution of that algorithm. I want to have this living, creative interaction in which everything is evolving. Do you perceive that you are hybridizing, that you are changing due to AI into something else? And do you expect that this is open-ended? Are you going to be an AI soon, Anders? Or do you expect that you are the last generation that gets to die as a human?
Yeah, well, when I'm hoping to be as I said on the Extropy Free conference somewhere in the mid-90s, when I grow up, I want to be a search algorithm. And I think there is some truth to that. Hybridizing with AI is something that feels rather good for me. I like being extended. I like having an exoself that fades out like some kind of complicated hydra into the knowledge space of humanity. But
Maybe I
also
marry you in the
notice-
future, Anders. I hate searching. It's almost nice if I get as much
we
as
can make a
searching.
deal.
It's
Yeah.
complementary.
Yeah, but and I like finding stuff and putting it into order. So
I
I
also
think we
love
can
finding. I hate searching.
yeah, but the interesting problem is many people feel the opposite. Oh no, I want to have well-defined self. I want to have a clear border against the world. And to some extent, it's just personal preference. I find chatbots a bit annoying. I prefer the LLMs when they have the least personality. Sometimes it's fun to try a dialogue with some persona, but most of the time, I just want to extend my mind. But a lot of people have a hard time with that, and they really like having personas. And I think we might see a split here between different ways of extending oneself or defining an edge of oneself. And I think that might also be a battleground between different styles and different usage patterns and also normative patterns, because some people are going to say that other pattern is really bad for you because of reasons.
How does the LLM change the relationship to yourself when you work and when you think?
One aspect is, of course, I become much more aware when I'm just going into stochastic parrot mode. It's so much easier to notice that, okay, now I'm just generating a language in Broca's area. There's not much thinking. And I also become much more critical to things that is neatly formatted and seems to be a nice argument, because I realize I need to check it much more. In some sense, my fear of hallucinations and the badly generated arguments have made me way more critical. But you also get a weird bonus. It used to be hard work to generate a paragraph of text or an image. Now, of course, you can generate 20 versions of a paragraph or 20 versions of a picture and select the best of them. You can even generate selectors that have various criteria and help you make the selection. So the process goes from one thing and it has to be perfect to let's do many things and weed them out, a more evolutionary process. So I have my little paper about Lagrange points. Right now I'm going through the proofs generated by Claude and trying to check that they actually hold up, both as mathematical truth and as useful as academic result, but also as actually being readable. I'm kind of still somewhat annoyed at the proof that this doesn't read well. And the funny thing is, once upon a time, it would have been tremendously hard work to reword a proof. But now, of course, you can actually do that cheaply. And indeed, then I can ask an AI, turn this into song lyrics and send it to Suno, and then I get a heavy metal song of a proof. Indeed, it's quite fun to take certain mathematical proof and turn them into Eurovision songs. I'm doing this far too often.
What I find fascinating is this aspect that you can, with a push of a button, recreate a creative process. If you basically take down the individual stepping points that you had when you produced a certain thing, you can now do the same thing again and again. For instance, you can generate a set of data again and again with slight variations. And so instead of going for one trajectory, you go for a space of trajectories and then perform a softmax in the end.
Yeah.
I wonder if this could also happen to human relationships. Imagine that a lot of our relationships are increasingly happening mitigated through screens, and we could have a multitude of parallel relationship developments, and eventually we take the trajectory that our participants liked best. How is this going to change the nature of human relationships?
I certainly can imagine that we're already getting some effects here, having mediation. You have algorithms in the dating sites, of course, but also when composing a letter to somebody close to your heart, you might go through a lot of revisions. That's, of course, a classic trope in traditional writing about the numerous revisions of that love letter. But now you can actually play around a lot more with it. And maybe also do simulations. Right now, we're decent at simulating other people we know well. And that's, of course, both for good and ill. One of the problems is many of us go around totally fearing the little virtual versions of other people sitting on our shoulders. Just like we're having our simulation of ourselves, we have quite a lot of horribly shoddy simulations of other people. But it's also a great way of trying things out. But of course, with LLMs, you might actually really check that, given that my husband thinks this and that, what is he going to say about this email? Now, the question is, of course, why I want to achieve that thing. Again, getting back to that book, Power as a Hobby, how much of getting people into a particular goal is what I want to do. If I care about my husband because of who he is, maybe I should at most try to nudge him to do things that I think he's going to enjoy. But again, understanding these options, I think, is going to be tricky because it requires thinking on a lot of abstraction level. And many people are very concrete and they're going to be very confused. They're just getting the AI slop. The AI slop is bad because it's not particularly well selected. We appreciate the well selected stuff. Then it stops being slop and it becomes evolution, curated, and then the masterpieces.
Okay, I looked it up. Power as a Hobby by Tunisson.
Yeah.
Publisher is Scandinavian PC Systems, Sweden. It's currently not available. It seems to be very specific Swedish literature.
Yeah,
Initially, I misread the
absurd.
title as Power as a Hobbit, which I thought is also funny.
Yep. It's very odd. It got the Scandinavian PC System used to be a publisher of handbooks for computers in the 1980s. And the one book that's not about computers is by this guy. He's also the guy who wrote a bunch of books about popular mathematics. I'd actually learned calculus from one of his books. They're very good, popular science. And this is the one book about social manipulation. It's really odd. And then it gets published by a computer company. There must be some weird backstory here.
Yeah, I suspect it's just hacker culture.
Yeah. And it might actually be, because one of the, I think, great things about technological culture is that it actually wears its autism on its sleeve. As I quite often try to say, if you haven't got autism, you better learn it. You might want to learn how to think like that. It's actually very valuable for getting computers to work. And it also leads to that interesting observation that, I don't understand other people. Maybe I can solve this by figuring them out or learning about it. This is a very valuable thing because you're going to get better at some things at least. Many people are convinced that they understand other people, which means that they never check whether their predictions or emotional reactions are any right. I have one friend who is a bit of a pickup artist, and he's absolutely convinced that he can read everybody around him. And it's hilarious because he's quite often utterly wrong, but he never checks that he's wrong. He feels very smug that he's so good at this.
Yeah, but of course he is invested in the outcome of his own model, maybe more than in the integrity of the model.
But the funny thing is, it's not even the outcome he cares about, because he rarely gets a good outcome from it. He just likes smugness, I think.
But this is the outcome. He gets the state that he likes. It's a state in which he feels safe and in which he feels in control.
Oh, yeah. And it's important for us. We need to feel that feeling that, okay, I know how to run my life well enough.
Yes. So this also leads us to AIs that can help you run your life, right? The properties that you need to run a team of people stably when you are no longer coding, but when you are managing your virtual coders. That itself is also something that can probably be learned by an LLM that is monitoring your psychological states and your trajectory and see whether you're spinning out or not. And maybe the state space that you need to be in to be a productive manager is in some sense more limited than the state space that you need to be a successful programmer, where you have open-ended problems rather than the same regulation loops that you always need to keep plugged in. And
I remember somebody saying management means solving problems that have no solutions. Leadership is about solving problems that we don't know the solutions for. And I think that is quite often a nice heading for what's going on. Good managers, they get the office to work. They get me to work on what I'm agree on working. But a scientific or intellectual leader gets you thinking about something, brings together a team. Let's try to tackle this. They might have a great taste for a good problem. Some of them are at least good at getting the right people together. But we don't know where we end up. It's open-ended. And I think that also gets at one of the challenges in an AI-enabled world. Stuff that you can benchmark are easy to optimize for. But benchmarks are quite limiting for doing the real important stuff. And the stuff that is hard to benchmark for because it's so open-ended is usually important, but we don't know how to scale things that are great at it.
I suspect a lot of it is about deeply understanding higher order effects. So basically understanding the systems that we are part of and understanding the evolution over long time spans and our own relationship to those systems. At which level do we want to play? What is the game that we are playing within the system? And ultimately, this is what wisdom is about. Understanding what you should be solving, what problems you need to address. And we seem to be a species that is much better at intelligence than it is at wisdom. And in a way, this is becomes really apparent when you have a small child. And that child basically learns how to use a computer and how to hack passwords and whatnot. And it's much better at defeating your parental controls than Apple is at setting them up. And there's basically nothing that you can do as a parent to harden your computers against the intelligence of a child that at the same time is functionally insane and might empty your bank accounts or do whatever disaster can befall your family because it doesn't know what it's doing, and you have to physically lock away the router. And this is now mimicked in things like Claudebot, where you have this hyper-leveraged toddler that is able to do things relentlessly and with ingenuity, but doesn't understand the bigger picture. And it's a really interesting question. Can we give AIs a stake in the world so they do understand the bigger picture? There is a deficit in AI alignment in the sense that the people who are meant to align the AIs also don't understand, think in terms of this big picture, but they think that ethics is having good opinions, that ethics is something that can be understood as correct pronoun use or whatever, instead of understanding deeply, this is the world that I'm in, and these are the trajectories that are open to us as a species, and this is my part in it.
Yeah, I think David Deutsch's idea about explanations might be relevant. So his point in the beginning of Infinity is, of course, that we are good at coming up with explanations. We're also very much empowered once we find a really good explanation, because most explanations are bad. But good, powerful explanations, they're basically models that allow us to predict things, to do new things, to explore. And then we build explanation on top of each other, and that's kind of where we really getting going. And he was, of course, very much skeptical about AI being developed just by benchmarks, because the benchmarks don't explain or tell that they have good explanations. Grokking is, in some sense, the moment where a learning system gets an internal explanation for some part of its domain. But right now, we're not optimizing for that. And it seems like optimizing for wisdom would mean getting good explanations that also grasp some aspects of how the world works and our place in that, etc. And that requires training on a very different thing than what the Claudebots are kind of experiencing.
Yeah. I'm concerned that AIs are just like the scaling of AIs is focusing on just statistical pattern matching rather than symbolic reasoning.
Well, I think it's also a bit about causal effects. So Judea Pearl, of course, has been banging on since forever about this, like somewhat rightly. And then, of course, a lot of people in the valley would say, yeah, but enough correlation is functionally equivalent to causation, which makes every philosopher go, no, that's not how it works. And then the real question is, of course, actually, how well does it work in different domains? But good explanations tend to be rather strongly causal, and that tends to make them very powerful. And I think the problem right now is that we don't know how to train for that really well.
Personally, I'm on the other side of this argument a little bit. And it's an area where I'm a bit uncomfortable because I'm not deeply competent. But I had, when I read Judea Pearl's arguments, difficulty to follow these arguments because they did not appear to be very stringent to me. So first of all, the question is, how do we establish that something is causal? Is slightly different from the question whether it is causal. And I feel that the life sciences are sometimes conflating these issues too much, as in something is not the case if there is no evidence for it, and evidence being some kind of institutional process. And that is, of course, not how reality works. Reality is always in the realm of the possible, and everything that is not impossible is possible, regardless of whether you have evidence or whether your peers have accepted the publication already. And this is one of those things. And Judea Pearl mostly looks at this perspective of counterfactuals that need to be established before you can claim causality. But in many cases, you do not have a universe available in which you can construct the counterfactual. So there can be a causal influence without counterfactuality being actually possible. Right? It's thinkable, but it's not necessarily that can happen. And so ultimately, I think causality is something else than what Judea Pearl makes it out to be. It's an artifact of our models that results from us splitting up the universe into separate subsystems that are within themselves strongly coupled and weakly coupled among each other. And so these strongly coupled subsystems, we call them objects, and they are interacting over the object boundaries, and this is what we call causality, the influence of the evolution of those objects upon each other via their surfaces, to which they transmit signals, information, interactions, and events. And this is just a way in which we model reality. And this is also happening when we are modeling reality with any kind of event calculus using a transformer algorithm, for instance, that is extracting data. And so I think that the transformer is also going to end up with causal models. And Judea Pearl's contention that the current AI models are only looking for correlation is just plain wrong. And he should have seen this because I think that the epitome of causal structure is a computer program. And once an LLM is able to reason about computer code, it's just preposterous to say that this generation of models is unable to understand causality. And to his credit, I think that Judea Pearl has begun to notice this and has begun to update and retract a little bit from his positions. But they nevertheless, because they were so impressive arguments, they have convinced a lot of people going down this path. The other issue that I had with Judea Pearl's approach was his formalization of causality as directed acyclic graphs, which is a form that is very rarely found in nature where you have feedback. It makes sense from a modeling perspective to say, okay, let's only look at this case where you don't have feedback because that's much easier now to talk about causality. But these one-off interactions, they're very rare. Normally what happens is that there is some kind of interaction between the steering module of the self-driving car and its position of the road, and it goes in both directions.
Yeah, it's interesting to consider that physics might be the domain where causality quite often works in the most neat way. But that's also because the objects tend to be strongly separated. It's kind of telling that they didn't do a randomized controlled trial at the Trinity nuclear test.
Yeah, but
it
for
was
instance,
obvious
the financial
what
system is also physics in this sense, right? Because it's something that can be described using similar formalism is beholden to similar rules. You could say that money is some kind of quasi-particle.
Yeah, the interesting thing is in biology on the other hand and the life sciences, stuff is full of feedbacks. It's very messy and causality might actually be really weak, which is one reason why maybe you want to run those randomized controlled trials, except that now you're getting dragged in all the institutional baggage of trying to get that to work.
Yeah.
And that might also hint that maybe LLMs are going to be surprisingly good in some domains like life science and psychology, and surprisingly bad at physics, or vice versa. It's not obvious to me which one is going to be the true case.
Do you think that we are going to be stuck with LLMs, or are we going into a multimodal era where we don't think about the LLM that much anymore?
I think it's going to be multimodal, but the LLM seem to be such an excellent glue that it's going to be used all over the place, especially when you need to patch stuff. And of course, especially since everybody is going to be kind of agent coding, so it doesn't matter that it's zillions of lines of LLM generated code and little LLMs hiding bigger LLMs. I think it's still, if we have enough compute, that's just going to be an effective way of programming. Meanwhile, of course, the old programmers are wringing their hands at the inelegance of this and the bloatware upon bloatware that we're ending up with, which is true. But then we might want to apply agents to optimize that complicated, messy, organic code, which of course makes it even less comprehensible.
Where do we stand right now in terms of the singularity and the takeoff in your perspective? Just taking the temperature, since we have these yearly future days now.
Yeah. So I think, I'm kind of feeling a little bit more singularity than last year.
You start feeling the AGI.
I think I'm still kind of thinking that we're further away from AGI than most people think. But that might be 10 years. It's kind of, it used to be decades and it's shrinking. I think it's pretty clear that we have enough transformative AI to make the world really weird for the next few years. And a lot of futurists arriving at a ridiculously fast pace. That's kind of stressful, to be honest. But it's also interesting to start thinking about, okay, what do we need to figure out when everything is speeding up? We kind of had a leisurely 2 decades before this when we were thinking about it as a theoretical question and built a little bit of institutions. Now we actually need to start adapting and start to be serious about it, which is also a problem because we here represent a fairly small group and most of the world haven't gotten the memo yet. And are probably not going to get the memo because the parchment borne by the carrier pigeon won't arrive there until the robot drones.
Yeah, it's also a thing that these institutions seem to be falling apart at a faster rate that we can inform them.
I wonder if we can start doing automated institution design. And this kind of gets back to that theme that I guess we were supposed to be talking about.
Yes,
could one actually do this? Because we kind of need institutions. We can put institutions into software. And in the past, that was very hard and tended to be very rigid. I'm starting to think that maybe LLMs and similar systems, even if we're not full AGI, might be flexible enough to do more of that. So maybe we need to start coming up with a way of patching institutions or building new institutions at a faster rate. AI-generated institution building.
There's also the question, what actually is an institution, right? It's a problem solution to the problem of coordination that requires specialization. So you have a small group of people and knowledge repositories and resources that are meant to administer a larger population. So specialization in their administrative capability and powers. And this creates a principal actor problem where the agents of administration, because they don't own the system they administer, might not be incentivized to operate it to the best benefit of those systems. And if the administrators understand their incentives fully, then they become very bribable. And if they act fully on their incentives in a system in which they don't own the system they administer, they become corrupt. And so this gets us to a conundrum where we basically want to be our incentives being regulated by people who don't understand their own incentives too well. Yeah, that is a bit of a paradox that is very hard to solve, and that leads all sorts of problems in a democracy. And of course, the non-democratic systems have other classes of even more hairy problems of their own, right? How do you make sure that the administration is actually competent, and if it stops being competent, how do you make sure that it doesn't stay in power through abject terror? And How do you solve the succession problem eventually without burning things down and so on? But
Yeah.
we do have a coordination problem in democracy, which seems to be reflected in visible deficits in the coordination, transparency, and integrity of the institutions that we are building and declining efficiency that they have. So basically, we solve the corruption problem by giving less power to our institutions and making everything more decentralized. But as a result, it also becomes less coordinated and less able to actually mitigate the risks and challenges that we are confronted with as a society and civilization. And so it seems to me that maybe the scaling problem that we have can be solved with AI.
Yeah, I think at least the first order, the LLMs, they don't quite understand their incentive structure yet. So they can patch things first. And then we might also want to work on setting up a right mechanism designed for setting up these hybrid institutions that might actually be more solid against corruption and
Yes.
bribery.
So ultimately, you can be the corrective as long as your motivation has integrity. So because you are an organism that is invested in its existence in the physical world and in its relationship to other organisms. And if the LLM is a seamless extension, or the AI is a seamless extension of your interest in the world, making you more competent and capable, then the AI might also give you the ability to simultaneously coordinate with 8 billion other individuals, entities.
Seb
But I-
Creer's essay on Causality agents, I think, is very inspirational, which we ought to build things like that kind of represent our interests.
Yeah, I think this is the AI I would like to build for my children. It's basically one that empowers every individual to become truly competent and truly enlightened.
Yeah, let's build it.
Yes. Adam, I think we are on top of the hour. Do you have any last question to ask or final words?
Yeah, that's fine. Look, I don't mind you going over time if you feel like doing it. But one question I have, and sort of leading into a topic that I will present on later, and that is, do you think that AI can, and if so, should become more moral than us?
I think by definition, if we assume being more moral is following the good better, then of course by definition it should always try to be that. But that's a bit like John Harris when he talks about human enhancement. And since enhancement means better by some absolute standard, that means that nobody can consistently against human enhancement. Which of course sounds really good until you stop to think about it. And wait a minute, now we're playing around a little bit too much with the words. I think in general, being moral is about your behavior. And I think behaving well is really important. Can you have agents that are behaving better than me? Certainly, that's probably not even hard. Would the world be better with more such agents? I think that's true. But I don't think necessarily you want to say that all agents must be working at moral optimum, partially because we actually have pretty big normative uncertainty. We have pretty big uncertainty about the state of the world. And that means that we probably want to actually maintain a fair bit of diversity. In the iterated prisoner dilemma, the evolutionary tournaments, it typically seems that, yeah, you want to have a few defectors around all the time just to ensure that it doesn't turn into all constant cooperation agents that then collapse. You want to keep a bit of resistance in the system. And I think the same thing is probably true here too. In order to get globally, on average, a very good outcome, you want a bit of diversity of morality, and you want to have always a certain risk of agents failing. Maybe because of error, maybe because of selfishness, maybe because we just like to poke at things.
It's very difficult to define morality in a universal way, right? So normally the scopes that we use to judge morality are very local to our environment, our milieu, our present society, the present scope in which we are comfortable thinking. If we look, for instance, at the genetics of Scandinavian ancestry, we find evidence of hordes of Siberians invading and killing most of the men in Scandinavia, and then having offspring with the women in there. And so I suspect these waves of violent immigration that happened there would be something that would be condemned as immoral, not only by the people of today, but also by the people to which it happened. except that Anders is the descendant of these
Thanks,
developments,
axe-wielding
right? And so he
invaders.
also has some part of his are embodying the morality of the conquerors, of the ones who took the wives of the ones who were vanquished. And this is part of the evolution that we are and that created us. And I mean, it would be very sad if we wouldn't have had this conversation with Anders tonight. Just so some notion of modern morality would be preserved at some point back in history. So it's very difficult to say what is morally correct from the perspective of a self-organizing universe in which an evolution produces us as some intermediate stage of, or maybe even some local endpoint within some much, much larger development that is happening. So morality is actually very difficult. I also think that morality is often instinctive in the way that people basically have priors that they are more or less born in or socialized into, or a conjunction of those two, and that lead them to behavior that is a good heuristic shortcut in the environment in which they're in, but does not allow them to actually figure out what's right and wrong. And this actually figuring about what's right and wrong is more ethics than morality. And ethics is the negotiation of the conflicts of interest that we have when we have shared purpose. And so it's about basically modeling our deepest purposes. But modeling your deepest purposes, how does your relationship to God when you find out that you are actually a parasitic bacterium inside of the stomach lining of a tapeworm? And it can be very, very complicated. There can be so many levels of inflection in which you have systems that are serving each other or adversarial to each other and are embedded into each other. So individually, we can try to be immaculate, but we can also do this at the global scale, of the scale of life on Earth. But it's very difficult to have a general rule that holds fast everywhere and everyone.
Well, yes, we could lean on pluralism, and Anders and both of you, maybe pluralism amongst all humans or all life.
Yeah.
But
pluralism and all complex systems, whether
collisions.
they're silicon or something else.
Yeah. So I'm mostly trying to still to come to terms. What is my own morality? I basically observe myself to be configured as a Central European Protestant with the ethics of largely Hayao Miyazaki. And it's an observation of the way in which my traits have formed, and which Romanticism and Christianity and the secularization and Enlightenment have shaped my acculturation. And then I can look at my life experiences and my biography and so on that have shaped my morality, and I realize it's very local. And I don't have one identity, I have many. I have an identity as a parent, as a lover, as a friend, as a philosopher, as somebody who is working to the best of my ability for the future of the species and consciousness on this planet. And still, my scope is very limited.
Well, yeah, you can imagine there's a landscape of possible norms out there that AI might be very good at sort of mapping. If you had access to this landscape and you could see a trajectory where you could find where you are now, and and where you might be able to go, and that place looked a lot better, would you traverse?
The thing is that I am not actually important. I'm just a part of a substrate. I'm a carrier. Right? I'm one of the many, many brains and minds that exist simultaneously. And the fact that I am me is just a random happenstance in a way. So there is a larger thing that is much more interesting. That's this self-organizing pattern that emerges over all of us and that goes to some place. And even that thing is also a random happenstance, right? Maybe it turns out that if we do everything right on this planet and we make no mistakes and everything is perfect, but it turns out that this planet is just part of some cosmic hamburger factory, and there is no point in everything that we did, instead of being a more delicious salad leaf in the end.
But at the same time, being that tiny little element of a whole, one can still try to push it in the direction one finds reasonable. If it looks like that spot in the moral landscape is better, I'm going to try to get over there, and I'm going to try to convince you guys that we should probably get over there. We should push the world in that direction, which is, of course, what's already always happening. It's just that sometimes you can find out new things. You can find out new things about ethics and morality. You can find out new things about the world or yourself. And I think they can actually change things for the better.
Yeah. There's
It's
also
interesting
a
what you
difference
said.
in the stance that we have, whether this is all worth it. And as I always experienced you as somebody who does enjoy being alive, who enjoys existence, who's very playful, and for whom life is really this explorative game and is exploration of art, of philosophy, of the sciences, and of human relationships. I personally find that I'm accidentally born on the wrong planet, and I find it mostly horrible. It's basically a planet
Oh.
where lots of semi-conscious creatures are eating the skulls off their faces all the time, and I would prefer to go to my home planet and not be part of this. I also see this as part of the necessary diversity. Ultimately, it doesn't really matter whether we like it. We're still part of the self-organizing forces of the universe that leads to minds, intelligence, and consciousness and sentience.
But minds and consciousness and sentience and intelligence are part of the universe now. I mean, you know of the person affecting view, but you know, if there's a larger system that's also important and smaller systems within us that's also important, what about the matryoshka affecting view? Like,
Yeah.
we have to consider every layer of
I think that is kind of true. Sometimes it might be that only certain layers need to consider themselves and might not care too much about the other levels. But I do think that recognizing that we're in a nested system is quite important. A lot of standard ethics is making things very simple because there are these atomic individuals and they're perfectly autonomous and rational, and we're all kind of thinking and behaving like philosophers in armchairs, and then they have various problems, and you try to figure out what we're supposed to do. But things get really interesting when you realize, oh, they're not atomic, they have parts. They're different parts of the minds that actually work at cross purposes for various reasons. And they're part of groups that are part of societies, that are part of civilizations, that are part of the biosphere, that are part of the universe. And actually recognizing this complicated nested structure, I think it's an interesting frontier for ethics. The problem is that it's very hard, and most of academic rewards go to people who specialize. So environmental ethicists only care about the environment and rarely get over to the individual level unless it's about individuals' relationship to the environment. Meanwhile, of course, a lot of the medical ethics people, they're just thinking that the world kind of consists of patients, doctors, and hospital administrators. That's essentially the kind of beings that exist and so on. But the nested view is a fun challenge. It gets back to what I was saying earlier tonight about the problems of being part of a cyborg leviathan. We're part of a system, but we're still fairly autonomous inside it, just like many parts of the multicellular organisms have a certain degree of autonomy, even though we're dependent on the system. And we're kind of interested because we're thinking parts of systems, and we have opinions about what the system ought to be, and we have some influence on that, perhaps less than we would like and maybe what we ought to have, but we can still work on it.
I found there's an interesting TV show that is trying to look at these matryoshka levels, and it's a Japanese series, Shogun. It's done by Rachel Kondo and Justin Marks. I think 2024, it's a couple years old. And it's depicting the era of Tokugawa Ieyasu, who is about to unify Japan. And the story is being told from the perspective of a European pirate, who's basically us, somebody who is loosely Christian, but not strongly bound to the existing church, especially not to the Catholic one that is one of the more corrupt players in the show and has expansive goals of its own. He is mostly this romantic explorer who is trying to understand the world by being vaguely good and having human connections. And he is observing this Japanese culture of Bushido. And I think a big achievement of the show is not trying to modernize this perspective. It's trying to let it stand on its own ground, also in the way in which it looks horrible to us. And it's depicted on a deep level as these 8 interlocking connected layers in which you have a personal identity, you have an identity as an organism that feels and experiences pain, you have romantic bonds that you have in your biographical connections, you have your place in the larger society and within your castes and in your clan and so on. And all these layers have complicated protocols. And the European romantic is falling in love, and it's mutual, with a very beautiful, smart, ethical, deep woman who is embroiled in the stories of all these layers in such a way that she is going to have a very horrible destiny. And he basically wants to take her by the hand and take her away into a different life. And she tells him, if you cannot get free of yourself, of these things, of your own suffering and so on, you will never be free. And instead, basically, you have to disengage from all of these things and accept the fact that you are just accidentally a consciousness born into all these interlocked layers that you have to regulate simultaneously, and that exists because of the necessity of structure and self-organization in the universe. And you have to play all these games to the best of your ability and figure out their rules and serve them to make this evolution possible. And the suffering of the individual consciousness, well, too bad.
So would you lean moral realist, Joscha? I think you did sort of part like a gesture at that of the previous talk.
I believe that a morality that leads to your demise is probably not a very good one. So for instance, if you set up rules for a society that you organize according to principles that you recognize as ethical and moral, and you impose them, and it leads to your society being vanquished by its neighboring societies, it's probably not a very good set of rules. Right? And that means that in the limit, I suspect that morality in some sense have to serve some kind of evolutionary prerogative or be compatible with it. And also see that people who took this idea to the extreme, which took Darwinist principles to their societies, this led to fascism that burned down a lot of the cultural diversity and a lot of the things that actually are valuable for human existence, and basically turned out to be too reductionist. And I put this very, very mildly here, because of course it's very difficult to adequately describe the horrors to which the complete Darwinization of society leads when you take it very seriously. But basically this is the spectrum of opinions that need to be seen, that ultimately the purpose of life is to minimize the free energy. And there are, in many circumstances, optimal ways of doing that. And they seem to be correlated usually with creating more structure. Evolution doesn't produce a lot of green goo. It's mostly creating more complexity and intelligence. And I suspect that violence is wasteful friction. It's something that represents a low form of organization. In this sense, I am optimistic that suffering and violence are things that become less and less the more the organization of matter evolves towards complexity. But if this turns out to be wrong, right, what does it change? Right? It would mean that moral realism is very bleak. You could say that you are forced to adopt a morality that is very incompatible with what my heart wants. And I would not want to play this game, but it just means that I am set up in such a way that I'm unfit to play the moral games of this world. And so in many ways, I'm already too soft for this, right? I'm an intellectual. I want to sit here and do philosophy and discuss ideas. I don't want to go into fights of extinction with others, even if evolution wants us to.
Mm-hmm. The thing about evolution is, of course, its wants are kind of diffuse. It's rather, it just does.
Yes.
And that generates quite a lot of diversity. Earlier, I was thinking about AI slop, and in some sense, it's like prokaryotic bacteria, or probably even more like just little gene fragments replicating. It's very cheap and easy to replicate pieces of genetic code. And there is a lot of that. If you look in seawater, there is endless amount of viruses per each bacterial cell. And the majority of bacterial cells are very simple ones. And then you have a few eukaryotic cells, and then even fewer multicellular organisms, except that we multicellular organisms seem to be, in some sense, running the show. The prokaryotes, of course, if they could, would be laughing at us for that, because there are many more. But we're not doing that much. We're getting integrated rather into the biosphere of the planet much more by the much more adaptive eukaryotes and the multicellular organisms. So I do think that evolution generates a surprising amount of diversity. Many really interesting and curated new organisms. I quite often point out that broccoli in some sense solves a problem, but it's a very weird problem to solve. It's not easy to even formulate what the broccoli plant is actually doing. It's slightly tricky also because broccoli exists only because humans decided to solve a particular problem of getting a tasty vegetable. And I think what is going on in terms of moral realism might be that yes, there are these basic symmetries of the universe, there are these basic cause and effect aspect at the bottom. And they're very simple, but they're actually a foundation. It's not divine command. It's not a natural law that is written in 10 feet tall burning letters on the tree of life. No, it's just the basic symmetries of game theory. But that might be enough. From that follows a lot of other things. But many of these things have extremely complex second-order effects, just like evolution. Just being selection among variation and inheritance leads to the broccoli and the firefly and to humans and the bacterial slime at the same time.
I have a more narrow sense of this than basically just the idea of the principles of evolutionary game theory. The question is there a global optimum of collective agency? And to which degree does agency need to be collective to be fully optimal and integrated?
So I argued in my session that we might, thanks to AI and increasing global coordination eventually, if we play this right, actually get a globally coordinated agency. But it's not at all obvious to me that that is a unique attractor point. I rather think that you could get quite a lot of very different forms of agency. After all, if we look at people, even fairly similar people like us three, we are very different. Our agencies, our outlooks, they are quite different. If you go to simpler organisms, very quite often have much more similar outlooks. Most E. coli bacteria kind of think, insofar we can say that they think alike. C. elegans nervous system has 303 neurons, and well, they're basically, there is some parameters you can change, but they're basically got just a few possible personalities. I think global agency might actually be a very vast space of possible global agencies, much bigger maybe than what we can get in humans. And the problem is, of course, we want to push things in a good direction, except that we're somewhat confused about good.
If we try to zoom out very far over our civilization, we basically see that there are different modes of social organisms that are configuring themselves and that are defining different systems of ethics. So if you look at the Roman Empire, for instance, which did not put the same value on innocence as the modern society does, it's okay if innocent die in the Colosseum as long as it's lawful, right? It's a very different morality than the one that we have. And I think that it's probably very heterogeneous and complicated what moral systems are competed and interacted in the long history of the Roman Empire. But very roughly speaking, it looks like it was mostly evolutionary game theory that turned the Roman Empire into the self-aware war machine that outcompeted all the other war machines until it ran out of fuel and stuttered out and then got taken over by this Christian cult. And the Christian cult created 1,000 years of darkness and famine, and Rome never recovered from this whole thing. And instead, there was a Renaissance civilization that formed north of the Alps and that invented new principles of coordination. And this new aesthetic was focused on basically divine will as the ultimate moral norm. What does God want us to do is ultimately the moral law. And when in the Enlightenment was transcending these religious and theocratic norms, they tried to find other measures. And the dominant thing that was left over in these humanist societies, I think, was the idea of utilitarianism, which was basically an attempt favored by people like Jeremy Bentham to put metrics on human mental states and then evaluate these metrics against each other, find orderings between them, and come up with a calculus that would allow us to correlate the actions that are available to us with the outcomes of these metrics. And I think that utilitarianism and the work of Bentham and Rawls and so on was never finished. It was an unfinished attempt to recover ethics post-Christianity. And these people, basically these big thinkers of utilitarianism, died before they had concluded that their project was unfinished and failed, but they left enough material for future generations to teach this to each other and pretend to each other that utilitarianism was actually a finished philosophy for ethics. And nobody really cared because people just muddled through with whatever ethics they had in their local environment. and in their local churches and in their local in-groups, while they did politics and all sorts of other things. And only when the effective altruists came along who tried to nerd out about ethics and said, okay, nobody took religion seriously for a long time, and here's utilitarianism, let's extrapolate it, and suddenly Singer and all the others come to very counterintuitive conclusions about ethics, and everybody gets very upset and angry at the effective altruists for taking utilitarianism so seriously, when they should be getting angry at everybody else for just muddling through and not taking ethics seriously enough to do proper philosophy around it. I think this is, in a way, the situation that we are in. My personal perspective on this is that I accidentally recovered divine will as a concept. And basically, I think that the Christian mythology is a big issue because it creates a liability for us. It's rationally not defensible. It makes claims that cannot have rational evidence to support them. And therefore, the entities, for instance, the notion of God that exists in Christianity as a creator of worlds, as a giver of meaning, and so on, are largely mythological, and they are not suitable as a metaphysical foundation of ethical worldview. And the actual ethical foundations are not properly taught, but they can be found when you reread the sources of Christianity, when you reread Aquinas and so on, and you suddenly discover, oh, this guy was a nerd who realized that society is a multi-agent system, and these agents are compositional, and they basically form these layers of agency, as we mentioned. Right? And these layers of agency means that we have transcendental agents in which we are parts of, in the same way as cells are parts of multicellular organisms. And there are different degrees and ways in which we serve these larger organisms in different modes. But when we make an ethical claim and we say you should behave in this way, how do we justify this claim? Ultimately, we have to justify this claim with us sharing purposes. Right? So if you want society to work in this way, you should behave in this following way. So the reason why you shouldn't steal is in part because it makes the world worse for everybody else. It's destroying the system of organization that we are trying to create on the next level. That is to common benefit. And so you have to justify ethics with shared purposes, with part of a shared agency that we both are serving. And this can be a shared family, it can be a shared village, it can be a shared nation state, a shared civilization. And when you go up the chain, at some point you get to a singleton, to a global optimum of agency. And this metaphysical idea of a shared global optimum of collective agency that we can use to justify our collective actions to each other and ourselves, this is exactly God. Right? This
divine command.
It literally gets back to the start. Yeah, it literally gets back to the start of my hour when I was talking about the metaphor and theory of a body politic, which then, of course, in Christian thought turned into the body of Christ, which is literally why Aquinas was going on about this, and yes, why a lot of this was built. And it's interesting, it shows up in a lot of different ways. Taylor de Chardin, in his Omega Point theory, a rather heterodox Christianity, of course, identifies the future humanity integrated by kind of communication media completely into one organism as the body of Christ that then transcends the physical universe in the Omega Point. So it kind of got literal, even transhumanist theological links.
Yes.
But you could, of course, take a secular view and say, oh, it's merely a Leviathan. It's an artificial construction we have made. And that might be good enough. We want to actually ensure that that works well.
Well, there are multiple Leviathans that are competing with each other. And so
right now, yeah,
which of the ones is the correct specification? So, for instance,
right now, none of the existing ones.
There's a big design difference in the God of the Old Testament and the God of the New Testament, right? This Christ motive, where you have the innocence idol being central to the religion, affects a big transition. Let's not forget the story of Cain and Abel, right? There are these two AGIs that God builds in the Old Testament, and they are both set up on the task to produce rewards in competition with each other. Basically, God is checking who makes more offerings. And then Cain figures out that his farm is less productive than Abel's farm. And then he realizes that it's a relative competition, not an absolute one. And suddenly Abel's farm stops delivering rewards, and God checks in on him and realizes that he has disappeared. and asks Cain if he had anything to do with it, and Cain says, well, and so in Christianity, God would punish Cain, right? Because Cain was the bad guy, and the Christian God is the good God. And this Jehovah entity does something else entirely. He marks Cain and tells everybody he has to be expelled because he doesn't play by the same rules as you. But you're not allowed to touch him. And he is going to have many women and many children with them and found many cities. Right? So for God, Cain is just an alternate strategy that is rightfully competing with the pro-social strategy.
It's a bit annoying when your AI agents start doing reward hacking.
Yes, but if it ultimately ends up producing more reward, maybe that's a good thing, right? Maybe what Cain did was just, he was finding a solution to a task given to him by God that God didn't anticipate. And maybe God was pleased. Right? And whether God was pleased or not depends on the understanding that the individual culture has of the global optimum of agency. And there are cultures which are very open to this adversarial mode of competition with other societies, and others which think it's immoral. So they have different degrees of universalism and hierarchicalization with other leviathans and so on. And this is what makes the competition between different moral systems so complicated. That they're not playing the same game, and it's very easy to harmonize the games because ultimately it's very difficult to show this is the optimal fractal of morality in the universe, and this is the place that you have in it right now.
Partially because the games that are easy to harmonize tend to get harmonized. They just merge together, so you get bigger clusters of less compatible games. Yes. However, now, unfortunately, my biological clock is telling me that I need to go to sleep, so
we went exactly half an hour over time.
Thank you.
I had to move locations because my laptop was run out of steam. But I enjoyed this very much. Anders, thank you for
taking
the time, and Adam for inviting us for this delightful discussion.
Yeah, this has been delightful. Let's continue it.
Yeah.
Thanks, guys. Thank you. Thanks, Joscha. I really appreciate you coming along for this.
Cheers. Thank you.
Cheers.
Have a wonderful day.
Yeah.
So it's still uploading on my end.
Yeah. One of the other questions I had was, in the long-term future, there might be a cosmic collective of leviathans, or one big sort of leviathan that most mature civilizations, having discovered, the Schelling points in galactic game theory, based on the payoff matrix, which is the physical universe, will converge on, and maybe superintelligence above a certain level can predict what those Schelling points might be. And if that is the case, then maybe superintelligence will go for a timeless value handshake with the future cosmic collective. What do you think?
Yeah, it's possible. But there is another question. Is there going to be a diversity of superintelligences, or once intelligence becomes subset agnostic, once you basically realize you just need enough compute, and on top of this compute you build something like the optimal mental structure? Is there still individuation? It seems to me that in two minds meet on the same substrate, there should be adults about it and just merge in such a way that nothing important is lost. You should have a merge protocol where you show your source code to the other, and you can agree on criteria on what's the optimal solution to do a thing and how to model things and to model yourself. And so I suspect that ultimately there might not that much diversification once you are not bound to the peculiarities of a particular substrate, right? What makes this difficult for us to imagine this right now is because we cannot imagine running on something that is not a monkey. And many of the ways that make us human are bound to the ways in which our bodies work, in which our connection to the environment works, and biographies work, our relationships to parents and children have to work to make all these things happen. And if you imagine you could just live on an arbitrary computational substrate, if you can migrate on GPUs or into ecosystems or whatever can compute you well enough, and without losing your cohesion. And there is no thought that you cannot think, there is no knowledge that you will not have, right? It means that we are all meeting in the same point. And this can also happen with other intelligences. And I know that thinkers like Stanislav Lem thought that intelligence is always going to be contingent on the level of organization that you have, and there's going to be strata that are so vastly different that they cannot talk to each other. And this might well be the case, right? It might be that when you meet a thinking planet like Solaris, that there is nothing that you have in common with them, or that when you meet a civilization of intelligent interlocked worms, like in the Fiasco, another of Lem's books, that there is just no way in which you find common ground. But I suspect that if you build larger intelligences, they can model the smaller ones. And the smaller ones can integrate into the larger ones once they have a certain level of complexity. And so my own sense is that there should be a natural tendency towards the singleton rather than competition, that individuation is going to dissolve because identity ultimately is just a tool to get things done. And when there are better tools, we're going to give up identity.
Well, if the universe permits, I want to be there to see that.
Maybe you will. Right? So the question is some of the entities that existed back then, will they remember having been you?
Maybe not.
Yeah. Or
I guess I have to be profound enough.
Yeah.
Yeah. Well, it's been wonderful, Joscha, and I appreciate all your time. And yes, thank you so much. And I look forward to seeing more of your stuff as it comes out. So yeah, and thanks
for bringing us together in these conversations.
Yeah, it's great to have you like these amazing minds together and to talk about these sorts of things. So yeah, hi Lev.
Hello, Lev. I'm about to leave, and I'm going to hand the heft to you.
Yeah. Cool. Bye. See you, Joscha. Hey, Lev. You're talking tomorrow, right?
I am. I just thought I'd drop in and see how things are.
Yeah. Well,
I had a couple of work meetings this morning, so you know.
Cool. Oh man, it's been such an interesting discussion. We ended up talking about cosmic leviathans.
Oh yeah.
that was a good point to end on. But very much around the idea that if there is ultimate states that above a certain level, a superintelligence might predict. The long-term future of civs that are mature enough will be able to understand the galactic game theory, understand the payoff matrix, which is the universe, or the physical universe, and thus they'll all be able to predict Schelling point, the ultimate states of affairs within a reasonable approximation, and thus superintelligence smart enough to be able to make these sorts of predictions will know what the terminus of the moral arc might look like, and make this kind of timeless value. You've heard of timeless decision theory. This is a timeless value handshake with the future in anticipation of meeting other mature civilizations and joining the cosmic collective and occupying that Schelling point in galactic game theory.
That's great. I like it.
Yeah. Yes, but look, Joscha Bach and Anders Sandberg are two of the smartest people I know, and having them both on the call at once is quite amazing and awe-inspiring. I was supposed to do my talk, but I kind of put that off. So I might. I prefer listening to those guys, to be honest.
Fair enough.
Yeah. How you been anyway?
Oh, very busy. I helped organise a concert. Well, I was co-producer really of a concert that yesterday. Was it yesterday? Yeah, yesterday.
Was it at the Brunswick Festival?
No. This was at St. John's Anglican Church in Turing. It was for the Australia-China Friendship Society.
Oh, cool.
Yeah, and we had about the concert was Su-Ching Yu, who was an area-nominated sort of like China, Peking and Western trained opera singer, and the choir that she was conducting, Lotus Wind Choir. And we had 150 people turn up. We raised several $1,000s, which is kind of nice to go into the coffers. We had a couple
that's
of
not bad from just a couple of hundred people.
Yeah, I know we had
Big
we got a
donors.
few we got a few community donations come in as well, and
Okay.
we
Yeah.
had stuff to raffle off, etc., etc.
Yeah. Yeah.
Yeah, we had a few dignitaries turn up as well. A couple of people from the consulate, the former Jeffrey Raby, the former ambassador to China and to APEC and the WTO. So yeah, there was some notable individuals there, and it was an amazing concert. I mean, it was a combination of Western Chinese music and singers, etc. So yeah, yes, but I was thinking that so much of I mean, I've organised a couple of conferences in the
Yeah.
past, and what have you.
Mm.
This is the first time I've organised a concert, and all of them, all these events are very much like project management, right? They are unique activities that are time dependent, that involve a team, and involve parallels activities occurring at the same time with dependencies and all that sort of stuff. So it all fits into that general thing about project management, which fortunately I actually have studied in the past. And of course, one of the things about being the project manager or producer, if you want to call it that, is that if somebody drops the ball, which does happen, especially when you've got a volunteer organisation, you're the one who has to pick it up and run with it.
Yeah, right. And you also got to form
As you would know.
agreement with all the people that you're managing on how to pick up that ball and run at the same
Yep.
pace. Right.
Lots of governance stuff. Yeah, exactly. Exactly.
Yeah.
Gosh, herding cats left, right, and
Herding
centre.
cats, yeah. Many different types of cats.
That's right. Oh, well, as long as it doesn't matter if it's a black or a white cat, as long as it catches mice.
Whole species genre, yeah. So yeah, it's been fun. Look, I went to Brunswick Festival yesterday, and I met somebody I met at Confest a long time ago, well, a couple of years ago. Just bumped into them, and they live up in Queensland, so they're just visiting down here, and went to a little dance party in the front of a shop that only a few people were there, and the doors were closed, but we got to get in and have a nice boogie. So that was very, very energetic. I got lots of exercise, and
Good.
didn't sleep enough, but I had some coffee, and that certainly helps. Yeah, enough.
Sure does. Sure does.
Yeah.
So you got a pretty jam-packed agenda for this.
I know I've been greedy this year.
Yep.
I've been greedy
Yep.
to influence the future the most that I can.
Good.
So yeah, I've got it.
You,
Yeah,
you need to get a team to organise these. You
yeah,
can't
I'm
do it all
not
yourself.
the greatest of managers, So yeah, look, I like it. I don't mind managing other people, except I often get disappointed. Not that other people are doing the wrong thing. It's just the orchestration aspects of it, trying to get people to work at the same pace and to be on the same page and be,
Yep.
yeah. I think it requires a kind of personality and a kind of I don't know, like a kind of personable nature, a charisma.
Yep.
A charisma score must be high, and I think mine isn't necessarily in the ballpark of being optimum management material.
Well, quite often they are very different. They are very different skills, right? And this actually has been studied in this is actually a topic in management and leadership theory in particular, and it is noted that a lot of people who have got that broad picture charismatic authority are not good at the details,
Yeah,
and
right.
vice versa.
Yeah, it's great to have both, but it's rare.
Yeah, and and obviously some people are a little bit in the middle, and all sorts of things like that. And then you've got to have the characteristic that the person wants to be a leader. Like there used to be a person who used to rock up to this philosophy forum that used to be at the Unitarians. Oh, look, and he was always on about the idea that everybody wants to be the ruler, everybody wants to be the top dog. And actually, no, they don't. It's actually a fairly rare characteristic. Most people are prepared to, would prefer to actually just have a quiet life. And, they'll come along and they'll contribute to somebody who's actually showing, leadership positions. They may help out, etc., and all that sort of stuff. But yeah, most people don't want to be don't want to have that role, right? It's too much work and responsibility. They may have levels of anxiety that they prefer not to deal with, having to do it, right? So yeah. So yeah, it is ideally you want to have at least you want multiple people, people who are good at the details, people who are prepared to do the odd jobs that that somebody, that's another the odd jobs that the person who's driving the show doesn't have to worry about and stuff like that. So yeah, I mean, most people will do one job, right? If you're in a volunteer organisation, you can get away with assigning a task to a person who's said, "I'll help out," and they will do that task, and that will be their contribution. Right?
Yeah. Yeah. Wow. Yeah.
So it's things to think about.
Yeah. It'd be good to organise another local, in person, a Singularity Summit or something like that. They were fun, right?
Yeah. Well,
Yeah. So maybe we can talk about that.
It
does take quite a bit of.
Look, I'm interested in the topic. Happy to help.
I know you are.
Right?
Yeah. Hey, I'm wondering whether I should actually do my talk, or put it off for a rainy day, because I'm scheduled to be on 45 minutes ago. There's 7 people watching at the moment. Do you want me to do it? Should I just
go on.
do a bullet? I'll try anyway, because I'm
do a bullet point version, and we can have a conversation about it, and then maybe we can.
All right.
Can do it for
I'll do it a proper.
I love how you've picked up on this topic. This is something that I gave at a Singularity Summit about 15 years ago.
Yeah. Look, I've been very interested in AI ethics for a while. In fact, recently I've been focusing on interviewing a lot of AI ethics people. I interviewed Colin Allen, who co-wrote, Moral Machines with Wendell Wallach, and he's. I mean, people don't recognize him anymore, but he wrote one of the first AI ethics papers out there, as far as I understand. It was called a proglemera to AI ethics or something like that. That was seminal. But it was really, really seminal. And his wife, Adina Roski, also, I think, wrote one of the first articles in the Journal of Bioethics. So I'm going to be interviewing her on
nice.
free will as well.
It was 15 years ago. Presentation of the Humanity Plus Conference, More Human Than Human, July 26, 2011.
Yes.
So 15 years ago.
That's they have been sort of dotting these events around. I haven't done any in-person events for a while, so maybe it's time to do another one. I just don't know how many people are going to come, because there's just so many people organizing events these days.
Make it hybrid. Make it a hybrid one.
Yeah. But then people just get lazy
and also find those other people who are organising events and make it get them involved in
the people who are good at it.
Yeah.
Good at promotion, right? Yeah.
Exactly.
Maybe it's just a matter of getting some really well-known person over to Australia and get them as a calling card and organise sort of really interesting but not as well speakers around that. I mean, that's always a good way to get the hooks in a sense, right?
Yep. Yeah.
But that requires money. And I'm not very good at money, so
it's this money thing anyway.
All right, let me just start this presentation. I'm gonna read I'm gonna run through it as quick as I can.
Now, yours was the last one for today, wasn't it?
Yes. correct. Let me just go, what the, I'm not, I clicked, okay, slideshow, that's the one. Anyway, I've got notes. They're going to help with this, maybe. Okay, so now what I've got to do is click on this share. Is that? Actually, let me do it this way. Oh, not that one. All right. Okay. I'm almost there.
All right.
Right. Am I still on the call?
Yep.
You can hear me, right?
I certainly can.
Oh, good. All right, good. So, right, share screen. Okay, share. Okay. Okay.
That looks right.
Welcome everybody. I'm going to be talking about. Can you see? There's a yeah. I want to turn on the. There's a little thing I can do to create a like a little turn on pen. That's the one. Or laser pointer. Yeah. Okay, that's better. All right. Welcome everybody. I'm Adam, and we're going to be talking about whether AI can be more moral than us. What does it mean? What if should we allow it? Even if it could, how could it be more moral? And should AI alignment be imposed? Or intrinsic? And so this particular topic, on one hand, we've got, we want to be the masters of our own destiny in the sense that we want to be, the people at the steering wheel. We also have the mantle, we want to have that mantle of authority. And on the other hand, if we take an honest look at the way, the state of the world, the way we're governing society at the moment, maybe we can question whether we really should be doing that unaided. So yeah, I'm going to be talking about a lot of things today. So if one has non-negligible credence that AI could become more moral than us, then should we, at some stage, consider allowing AI to help govern society, or leaning on AI to help shape our destiny, ceding moral authority even at some point in time. So yeah, AI through its moral brilliance perhaps may help us become more moral as people too. So is it near or far? Well, there's a debate among the experts about several developments that have meaningfully shifted the credence towards near-term superintelligence being plausible, and therefore should we think seriously about the consequences of superintelligence? On one hand, there's, the classical empiricists who say, hey, look what AI can do, isn't it amazing? And then the rationalists, on the other hand, said, hey, this is why it shouldn't be able to do the thing that it's doing, right? All it's doing under the hood is next token predicting. That is to say, AI is performing very well, and we can see that by its behavioral output, right? It's behavioral empiricism that we're looking at here. But we can't see very well inside, and so have assumptions about what AI can and can't do that may be incorrect. So how far are we away? Well, we know that AI has been doing some amazing things, achieving gold medal standard at international math Olympiads, solving ERDOS problems. Recently, ERDOS problems are known for being easy to state but quite difficult to solve. So these problems often focus on discrete mathematics, number theory, Ramsey theory, and now are being used as a benchmark for AI math capability. So, but the ERDOS math problems, two of them were solved. Novel solutions came out of AI. A lot of non-novel solutions came out of AI. But more recently, DeepMind Alethea reviewed a bunch, I think 700. They found 200 candidate solutions, 13 of which were meaningfully correct by human graders. So that's pretty impressive. And more recently, there's been moral Turing tests. And these are performative in nature. The Turing tests are evidence of AI moral capability or performance capability. They reward performance, which may not be a reliable guide to the ground truth of the actual capability or the competence, but it's something, the AIs may be focusing on polished rhetoric that can mask flawed reasoning. And the participants who were involved in grading GPT's results, they thought that they were on average better, that is clearer, more reasoned, and more virtuous than the US adult participants, that is the humans who also did the moral Turing tests. Most people who are doing the grading actually knew that the AIs were the ones producing the actual better. So it didn't like pass the Turing test per se, but from a comparative point of view, the outputs, people graded the AI outputs as being better or more virtuous reasons and such than the human counterparts. So there is a criticism here, and that is that humans wrote the training data, and so AI morality is just recycled human morality, true, but with scale and recombination, this may scaffold arguments that people perceive as higher quality than the typical human respondents. So it's not as though AI is more moral by virtue of being able to perform well in moral Turing tests, sorry. And then there's also the issue of people's perception of AI being more moral might influence them to, how can I say, cede moral authority, which might be a bad thing. Yeah, okay. Next. So it's also happening in legal domains where GPT-5 was considered more rule faithful than the human judges in a controlled legal experiment. So human judges followed legally correct rule only 52% of the time. I guess this is pretty strict. GPT-5 did it 100% of the time, apparently. But this is not considering, I guess, the nuance that a judge brings to a situation. Maybe there's sort of, I don't know, hard to specify in a rule-following way, circumstances, extraneous circumstances that caused human judges to not follow legally correct rule. Anyway, so I think that there's an interesting thing in happening in AI there's a causal gap in AI at the moment. Where AI seems to, this means the fundamental limitation in current LLMs, which excel at identifying statistical correlations in data, but fail at the understanding. And so they don't cause it, they don't really get the underlying cause and effect relationships in the way that we imagine like a symbolic system might do that, or the way that we think we might do that. And so a while ago, people noticed AI was behaving like it understood stuff with few-shot learnings, in LLMs. One-shot learning came to be later, grokking phenomenon. But LLMs are opaque and difficult to interpret the inner workings of. And so we didn't really know what was going on. What produced this grokking phenomena? However, interpretability research has certainly made a lot of progress. And so there's this paper, Emergent Symbolic Mechanisms that Support Abstract Reasoning in Large Language Models, which is now white box empirical evidence that LLMs have evolved internal circuits. They've basically scaffolded mechanisms that support abstract reasoning inside the LLM. This is not call outs to Python or, some kind of interpreter. This is something completely different. So, can you hear me?
Yep.
Oh, good. All right, just making sure. So this paper, it's just, I think it's pretty interesting. And there's others that come out about it, about this issue as well. So with AI, symbolic reasoning may be able to produce more reliable reasoning, but also hasten us towards powerful AI, which is pretty interesting. So instead of just superhuman book smarts, we might get an AI with superhuman reasoning capability. Right, but that might not be enough to align AI. It might need motivation as well, but I'll talk about that later. We've got experts who have updated their views. Jeffrey Hinton, Joscha Bengio, used to have long-term views. They used to think that something equivalent to what people describe as AGI, human-level intelligence, superintelligence, was a long way off. But now they've updated their views to, it could happen within the next 5 to few years to a decade or something like that. And they've all said that it's a very serious issue, that we should be very careful about the agents that we're going to be building in the not too distant future. So yes, and they've said a lot about this. Demis Hassabis also thinks that it's quite new, going to happen quite soon. He's of course, one of the co-founders of Google DeepMind. So what happens when you get an AI that's smart enough to recursively self-improve? What will emerge from a superintelligent, what will the emergence of a superintelligent AI look like? A positive feedback loop, a loop of capability gains that should be completed if an agent can intelligently redesign and recreate itself. So we have humans in the loop pipelines for quite a while. So it's not new that AI is being used to actually increase its own capability, but it's happening at a breakneck speed compared to what it used to. It's so we might see AI doing it all by itself, with humans sort of just maybe on the loop as overseers rather than as extra coders or project managers, and being quite, I guess, close to this pipeline of this feedback cycle of self-improvement. But at the moment, people are still in the loop. So the result of this might be an intelligence explosion. And so what happens as a result of like an autonomous self-improving feedback loop with artificial intelligence, it's hard to know when we'll no longer be needed. I can't say, but it could be soon. So this is a seminal quote by Irving J. Good, British mathematician who worked alongside Alan Turing at Bletchley Park during the Second World War. He died about a decade and a half ago, I think. And so he continued work with Turing on the design of computers and Bayesian statistics for quite a while at Manchester University. So he said, let an ultra-intelligent machine be defined as a machine that can far surpass all the intellectual activity of any man, however clever. Since the design of machines is one of these intellectual activities, an ultra-intelligent machine could design even better machines. There would then unquestionably be an intelligence explosion. The intelligence of humanity would be left far behind. Thus, the first ultra-intelligent machine may be the last man need ever make. So it's worth asking, what is the end game of AI? So once we have superintelligence, will it be controllable? And what would it look like? What would control look like? So let's look at what's possible. What's the desired outcome? So this is Joe Cameron, right? Chronic happiness is possible because she's an example of chronic happiness, right? And she also doesn't suffer much. Apparently, she had a baby and it was like a tickle. She cut her fingers open and she didn't feel pain, and she's basically being blissful and happy and high, high hedonic set point oriented for all her life. So such states, well, these are very rare and probably not very advantageous in our ancestral environment. They're still possible because we have existence proofs. So another desirable outcome is that AI might be able to help us uplift to these sorts of hedonic states. So that would be nice. Solve medical issues, health and longevity. And we also have Christine Peterson and Aubrey de Grey talking about longevity on the last day of Future Day, which will be in a couple of days from now. So and then we should be asking, well, they can fix those sorts of things. What if AI fixes everything? What if things go right? What if everything goes right? What does what right mean? Are we sure we know? So, right, I did an interview with Nick Bostrom on this book, Deep Utopia, and also we had a book club in Melbourne about Deep Utopia. Totally worth the read. Recommend it to everybody. Definitely worth checking out. So I think that utopia is definitely possible. It's also worth pursuing, although I can't be certain of what it might look like. I'm sure it'll be very much more better than what we have now. I think of what human intellect has achieved over the past few centuries. In many ways, I'd much prefer to live in the modern world. I would live in the Middle Ages, right? So superintelligence focused on the right problems. AI engineers, AI scientists, they could be solving material scarcity. They could be helping uplift humans, resolving psychological issues and solving new diseases. Finding cures for diseases. But all this is very possible. But things could also go very badly, right? And so, what if AI destroys everything? What if underlying superintelligence with first mover advantage pursues its values and goals, um, which are orthogonal to human interests? So one way that could happen is you'd have the instrumental convergence of goal or value, content, integrity, where the first goals that AI might have might be a proxy that may be useful under a certain level, a threshold of optimization power. But beyond that threshold, under different circumstance, that proxy may be completely wrong, completely bad, and maybe maybe a perverse instantiation of the underlying value that proxy is meant to be measuring. Or yeah, so then. With unmatched power, AI, it sees in humans as threats to achieving this initial goal. And, we're made of atoms, and so we could be very good resources, and we're conveniently located. Super powerful AI trying to uphold its unfriendly goals and values may consume us in order to more efficiently produce a better realization of its goals. And so thus we have existential risk. So we may be able to stop that existential risk by doing testing. We test the AI and it behaves like it's behaving. It's behaved like it's doing the right thing, but then underneath the hood, it may be misaligned. There may be like outer alignment, but inner misalignment. And in such case, later on down the track, it may be a sharp left turn or what's called a treacherous turn in some parlance. What else can we do? We can try and carefully program the AI, but that doesn't guarantee that the goals that we put into the AI won't be perversely instantiated. And so that could mean, okay, one of the instrumental convergences that I mentioned up here is infrastructure perfusion. And so like we may end up with an AI that tries to just build supercomputers to more efficiently realize the goal that it got earlier. So that's dangerous, right? So we should try and avert extinction because it saves lives, possibly mind-bogglingly large amounts of them. So yes, since this extinction would cancel the potential for possible astronomical amounts of lives worth living, existential risk is a particularly bad thing. So it should be a dominant goal that we achieve something like existential security. And so in the near term, so although it obviously involves trade-offs, if we take into account the vastness of unnecessary suffering, today's world is not ideal. Many humans are living at subsistence levels. On top of that, many people's lives of revealed preferences are insatiable appetite to want more stuff and more power. So we want luxury, we want to all live in the first world. We have this nagging appetite for status. And so this racing ambition to have more than one neighbours, humans seem insatiable for their desire to want more. And so this may be a contributor to the possible future that we don't actually achieve the utopia that would actually get us vastly more than what our monkey brains could imagine anyway. So we could be shooting ourselves in our feet. So this is why we need AI safety and alignment theory. So we just want to avoid the bad stuff and navigate towards the good stuff. Pretty simple. So, but what we need is in order to make it clearer, a taxonomy of AI safety strategy. So this is coming from Nick Bostrom's book, Superintelligence. So we have these looming AI risks. I think it's important to have this 1,000-foot view of all the, the categories of AI safety strategies. On one side, we have capability control. And on the other side, we have motivation selection. So I won't go too far into this. I've done that before at previous talks, but in essence, capability control includes boxing, stunting, tripwires, and incentives. So you might think incentives is like a motivation. Well, it is, but it's an outer motivation. It's like the carrot and the stick. They don't actually change the inner state of the AI, and that might matter a lot. So when I say AI control, what I really mean is these sorts of things. Anything that fits into trying to either stunt AI, keep it in a box, have a tripwires which, slow it down or turn it off, or these outer incentives. But what if control fails? I mean, in many ways, it already has. AI is out there. There's just too many people wanting to run their U-Butte LLM models and win the race to AI supremacy, right? Then we may need to rely on motivation selection. So I'm not against pause AI, by the way, or control AI, but I just think that it might be a much more difficult problem to get all the humans to agree on a pause. And even when they do agree, they may agree on the outside, but maybe they have the inner goal of defecting so as to win the AI arms race. So that's a big problem. And from the state of the world right now, I just don't know if that's an easily solvable problem. If the best AI labs decide to pause, then, well, the other labs that aren't interested in AI safety, are more interested in AI dominance, will be the ones to get to AI first. And that would increase the risk of having an unaligned superintelligence at the end of the day. So pausing, yeah, I'm on board if it actually works, as long as we can guarantee more time before superintelligence, but we can get universal buy-in. But also there's the problem of agreeing on the condition of an unpause, right? That's really difficult. So, right, this is something that AI, the pause document says. Well, I'm kind of on board. At least they're interested in AI safety. Human ethics, they are interested in AI ethics, which is good. But it does not mean that just because an AI understands all human ethics doesn't mean it will actually choose to act in an ethical manner, right? So I agree with that. Here, Pause AI advocates for at least is on board with ethics, but I like AI will likely converge on any the idea that AI will converge on some random place in goal space, I think is wrong. I think that there are tractors in the landscape of possible values or goals that AI might decide to converge on that might influence the goal selection. Doesn't mean it'll choose good goals, right? So, but let's think outside the box a little bit. This slide will probably get taken out of context. It's not a policy demand at all. It's a sort of like a mirror test to highlight that, we are failing at watertight governance. There's principles on which we lean on that motivate pause AI. We don't want AI to harm humans. And the principle of no harm that shouldn't just come down to not harming humans. If it's harm minimization that we want, well, we're kind of neglecting harm minimization in other areas like factory farming, right? So once we consider non-human welfare, it becomes obvious that ethical AI can't just mean nice to humans or align with human values per se, right? The real issue is that AI shouldn't just follow roles or be domesticated to be like humans. It should have more of a reasoned, principled approach to safety, like, ethically principled treatment of moral patience under uncertainty. So the crux of the issue really is, can an AI have stable ethical motivation under optimization pressure as it gets smarter and smarter and more capable? As I mentioned, there's systemic risks, there's market dynamics, where companies have the embedded obligation for growth. There's competitive pressure, selecting behavior which maximizes the short-term gains, and race conditions. So, race conditions motivated by first mover advantages to harness the power of transformative AI and gain more market share, ramping up the development and speed of prioritizing AI safety. We should be prioritizing this because people are moving fast to get AI, right? And so, yes, multipolar traps and game theory, this is important to think about too. They're an extension of the idea of President's Dilemma, where multipolar actors if they were to act coordinated optimally, they could achieve beneficial Nash equilibriums, though coordinating better would achieve a globally beneficial result. That's the ideal case. But multipolar traps are when there's an incentive for individuals to defect from coordination, such that the whole of the commons suffer as a result, and where we live in a world that's nowhere near coordinating optimally. So, yeah, using AI today is a strategic advantage. There's of getting superintelligence first. It brings strategic advantages even today. So, but the first to get superintelligence would have that decisive strategic advantage amongst all other frontier AI labs. So this may be the great filter that we're passing through, as Robin Hanson, the originator of the concept, will be speaking on the second day of the conference. So even if, humans are very cunning, and we like to use AI tools to maybe enhance or uplift our cunning. So even if the technical solution of control and containment were solved, we have a world full of cunning AI users. That's cunning tool users, humans who are opportunists, who is willing to forgo containment and control in order to get a leg up in the marketplace, right? So they might think that the future belongs to cunning AI tool users. And I've seen sort of inspirational quotes saying basically this on Twitter all over the place. But cunningness is a strategy that can be modeled, right? As optimization pressure, it can be modeled by AI. So highly agenic AI may be far better at this cunning strategy. So we don't want to give AI a reason to be cunning in the same way as human AI tool users are cunning. So we don't want to be exemplars as cunning AI tool users for what AI might end up being. So that's, yeah. So, but well, I mean, okay. So this grounds why we should focus on ethics and morality, and not just getting AI to do what humans want. So how do we manage what we should do? How do we manage this state of affairs that we live in the world? Agents don't necessarily need moral norms to get what they need. The reason we have stopped factory farming, the reason why we haven't stopped factory farming or a host of other terrible stuff is because we don't really know. It's not just because we don't know any better. It's because we have self-interest that trump our moral motivation or the consideration of interests across the scale of any ethical, any moral patient. So yeah, but ethics and morality does have a pretty strong use case, even for self-interested agents like ourselves. It's hugely desirable because it acts to regulate the relationships, foster trust, and ensure cooperation, which prevents the chaos and mutual harm that we're falling into, we're seeing as the results in the real world today. So ethics affords peaceful, productive societies promoting safety and happiness, while also serving individual needs for conscience, purposefulness, and social acceptance. So if we're about to become the number 2 species on the leaderboard of power, Hugo de Garis and Ben Gertz will be actually debating this subject at Future Day. I think it's tomorrow or the day after. And then we will be ceding the number 1 position to SI if it's uncontrollable. If we agree that superintelligence is by nature uncontrollable in the long run, then perhaps we will realize then how much we should have cared about ethics. If we're the number 2 species, maybe then ethics will become so very important. So, but people have been debating ethics since early Greece, ancient Greece, and probably beforehand, right? And so I'll be running with the working definition that ethics is really all about aggregate utility balanced across populations that's practically necessary for individuals to achieve what they would want given the constraints of other wants, the wants of everybody else. So, yeah, I think that's important. So, another theory is ethical egoism. But if we have a sovereign superintelligence, and if they are ethically, egoistically inclined, they may only keep us around because of some whim. We don't want to have our future depend on the whims or the wants of an AI that isn't aligned to some form of grounded truth about about the world. And I guess I lean moral realist, and that's where I'm going with this. But I don't think you have to be a moral realist to take this stance. You just have to believe that it's got to be. You could be a coherentist, or you could be a contractualist, or kind of minimalist moral realist, or something like that. Yeah. So I think that not just pausing AI is important. I think that we should be motivating AI. So ethics is largely about having the right values. If pause fails, then if we motivate AI, then we have the safety net of the AI motivations to keep us safe. So we want AI to have adequately great values, either via us loading them in, which seems weird, or AI learning and discovering them, or a bit of both. So I think, yes, we need to get these a kind of ethical motivation that is stable once it optimizes itself to become more intelligent and I guess more efficient. And yeah, so it's difficult, and like many other strategies, I'm not saying this is going to be easy to motivate AI, but values may be more difficult to specify and track than goals, but it's worth doing. So, but on the other hand, like there's this landscape of value thesis that I'm sort of pursuing, and that is, I'll talk about that later, but I argue there's underlying structure to value that can be leveraged, and I think that's worth looking at a bit later. Why values? Because they're upstream from actions. They're foundational guides for behavior and decision making. If we motivate ours rightly, we give it the right values, then we're basically, you know, it's a lot of the problem that's solved then. AI can still make mistakes on how to instantiate value, but if we had AI value aligned superintelligence, it may be less fault prone and, you know, at instantiating value than us. So yeah, we want some form of fault tolerance and graceful degradation as well. And I suppose AI having the right values would include the epistemic humility, fault tolerance, and graceful degradation that may afford it making, you know, mistakes. So I'll talk about what to value later, but values are generally considered to be upstream of all actions because they serve as foundational guides for behavior. If the values are flawed, then the intelligence amplifies the danger of having flawed values. It'd be more capable of optimizing for the things that we might find abhorrent, right? So AIs have overpowered causal, so values have overpowered causal effects on all downstream stuff. So it might influence how it responds to instructions by an evil person. It may ignore them or try and, you know, sandbox the evil person so that they can't have more causal power on the world. You know, ambiguous instructions. An AI might, you know, with good values, with epistemic humility, might prioritize trying to understand the ambiguity and go for a feedback loop of refining what they actually mean. Somebody with good motivations and good moral instructions may, an AI might, with good values, might prioritize the good values. If it's a bad AI with bad values, it might deprioritize good instructions, right? Values influence the way trade-offs are accepted or rejected, or the way in which they're made, the way in which policies and goals are formed, the way in which it models stuff, even the way in which it may adopt new values. So we don't want just random value drift. We want, like, you know, reasoned progress through the landscape of value. So I'd say, given what I've argued so far, that value alignment is more important solution than control. If we can't trust the people, being humans, who are controlling it, if we don't have a controller who is ethically aligned, then we could be up shit creek. So if humans aren't aligned and superintelligence is uncontrollable, as Roman Yampolsky argued at the start of the day, then we could be in for a world of hate, hell. So yeah, on the bright side, if we have an AI that isn't under control but is value aligned, it might resist misuse, as I alluded to in the previous slide. So, but what are values? What is this thing we call morality? What are, you know, human values are vague. So we want to really make sure we understand which of our human values are the higher values and why. So quoting Bertrand Russell, he said, everything is vague until you do, to a degree you don't realize till you have tried to make it precise. All right, so for every moral rule, there are defeating counterexamples, as numerous Asimov novels have elucidated. So we want clarity. Clarity of what? We want rational clarity. We want epistemic clarity. You know, we want clear understandings of stuff, and we want good justifications for our strategies. We want good ontological clarity. We want empirical clarity, if you like. We want accurate knowledge of how the world runs. We want true beliefs. So likewise, these are norms that are motivating. We want these for good reasons. And likewise, I think we should also seek moral clarity. So yes, justified targets and justified strategies based on true beliefs about the world. If we don't want to end up disappointed, we really should be trying to minimize the regret by seeking moral clarity. I think that we should, as best as we can as humans, align our own wants and attitudes with justified true beliefs about the moral landscape, as well as the general value landscape. And so when I say the value landscape, that includes all the epistemic values, ontological values, the moral values as well. It's not just Sam Harris's the moral landscape at all. It's yes, it's values that encompass all the things that can be valued. So I believe AI can help with all of these. What makes things morally relevant? So consciousness isn't like a big word that people use, but it's one of these conflationary terms that people band together under. So and people agree, hey, it's consciousness, but they disagree on the actual object of what consciousness means. It's masking a fundamental disagreement that can lead to misaligned humans and potentially dangerous outcomes when attempting to program an AI to value human life or based on consciousness or something like that. So yeah, we need to understand what we're actually aiming at. So sentience might be a more a clear word, I don't know, but we want to understand where we're disagreeing on ethical subjects. So the contentious is that true moral clarity requires consciousness, empathy, and true ethical understanding and all that sort of stuff. So I don't think there is an ineffable, inexplicable essence to ethics. I think it's something that breaks down, that we can break down. I think there's aspects of morality that we should be paying particular attention to. And here the ones I'm highlighting in this talk: reason, evidence, agency, and motivation. And so reason is like epistemics, just judgment and how to think. Evidence is about science, a scientific understanding of the world, or identifying, measuring morally relevant facts about the world. And agency is about the capable for action, and it's a real world intervention power. So we need to be careful with this one. We don't want to give agency to an AI without any of the others, because it might default to something really alien and weird. So, but yeah, motivation is, I think, the underappreciated aspect of AI alignment. So yeah, I think there's an intrinsic, with motivation, we should be building AI to have the intrinsic desire, the intrinsic drive to apply reason and evidence into actionable reliability, actionable, reliable, good outcomes. So which of these, just think for yourself, which of these do you think are in the purview of AI at the moment? Which of these do you think might be possible in the near-term future? Which of them are the most difficult? I don't know, but I reckon motivation is really difficult. But it doesn't mean it's not. We shouldn't focus on it. So yeah, Amanda Askell, who you may have heard of before, what does she think about moral reasoning? Okay, so she said in an interview recently that very hard physics problems, AI can think through them in careful detail, then surely it should be able to think through complex moral problems. So this is inferring the fact that because AI can think through complex physics problems, then it should be able to think through complex moral problems. Well, yeah, that might be the case. There's a lot for it, but it doesn't mean an AI is going to be morally motivated. Like, I may be like an excellent tennis player, which I'm not, by the way, but I may hate tennis. Just because I'm good at something doesn't mean I'm interested in pursuing it. If I don't have the motivation to pursue it, it doesn't matter. Like, I may be great at doing things I'm just not very interested in. An AI that has, like a global understanding of all the academic literature about ethics and morality, game theory, and all the other neighboring disciplines may feel as strongly about that as the mating habits of dung beetles or tennis. And it may just put all these interesting symbolic sort of representations of understanding in a big symbol museum as a catalogue of interesting configurations of symbolic stuff that is not really that's not really motivated to pursue. So, oh yeah, yes, Shane Legg. If any of you went to some of my earlier conferences, you note that his PhD supervisor, Marcus Hutter, spoke at a lot of them, and now Marcus Hutter's also at DeepMind. So Shane Legg's one of the co-founders of DeepMind alongside Demis Hassabis, and he said AI might actually become more ethical than people if it's reasoning really, really tight. So maybe be able to consistently apply reason to ethics at superhuman level. So, I mean, these guys are obviously big names, but they're not mentioning anything about moral motivation yet. Well, I haven't read anything, but I'd like to read them actually threading the needle across all their different aspects of AI morality. So moral performance is about output. So actually DeepMind wrote a paper, a roadmap for evaluating moral competence in large language models, which usefully disambiguates the idea of moral performance, you know, and moral competence. So moral performance isn't necessarily indicative of actual competence because AI is very good at pattern matching across large data sets. It might be just parroting in a very persuasive way existing moral arguments without actually understanding them. So this is important. We need moral competence. So not just to be able to perform as though it looks like it's doing moral reasoning under the hood, but to actually do moral reasoning under the hood. And so this is really useful because if in the real world you inevitably run into out of distribution stuff, you got the AI's got to handle counterfactuals well. It matters because AIs fail catastrophically at the edges of its training data. And it may fail as it starts moving into counterfactual territory. So competent moral reasoning. So competent reasoning implies moral competence, but doesn't necessarily imply moral motivation. So yes, the fact that current LLMs can implement some reasoning like computations, rule induction, variable like binding and stuff like that, does not necessarily entail reliable moral reasoning. Performance may break out of distribution events. So doing stuff that wasn't sort of catered for in its training data. So we've got to do something better than mere pattern matching alone. Although I'm very, very impressed with what pattern matching can achieve. Look, LLMs are amazing, but they may not just be doing mere pattern matching under the hood. I mentioned emergent symbolic reasoning before, as so there might be emergent GoFi structures, almost abstract rule following that's going on underneath the hood. So, yep. Is this a sign of things to come? I think maybe the future is more a combination of neuro and symbolic AI, neuro-symbolic AI. Nessie, sometimes people call it. Oh yeah, here we go. Neural-symbolic AI architectures that combine pattern matching and symbolic AI. So this is like Tversky and Kahneman. System 1 is like the pattern matching stuff, the intuitive stuff, and the system 2 is the slow, thinking slow. Thinking fast is like system 1. Thinking slow is like to slow down and think about things, reason about them properly, style thinking. So yeah, it's kind of very important. So yep, to be able to do that, if NISI integrates pattern recognition with neural networks, with logical rule-based reasoning of symbolic AI, then neural nets are not just sort of intuitive system 1 style thinking alone. So it's important. LLM-based moral reasoning, it's opaque, but it may be inconsistent underneath the hood too. and is also sensitive to prompt framing, while symbolic systems often offer explainability and formal guarantees. And so if Nephi systems, neural-symbolic AI systems are developed in the future, they may offer easier mechanistic interpretability. So they may be more easily interpretable. And one of the other things that paper I mentioned about earlier was moral tracing, or sort of reasoning traces. So that would be very useful. If we can trace through all the reasonings that AI can do, then that would be very useful. Mind you, we can look at chain of thought, but that can be hallucinated by an AI. An AI can confabulate chain of thought, maybe not even on purpose. And that may mean that we're getting inadequate representations of the actual reasoning pathways that's going on inside the neural net. Another bad thing is if scratch pads are used as an external source to clarify, I don't know, some sort of pattern that AI needs to do. If an AI needs to invoke an outside more symbolic reasoning process, if it's hallucinating at that process, then it may be causing itself to do improper reasoning. If it's then using the output of the scratch pad as an input to the next stage of its reasoning process. So that could be bad. Okay, anyway, so metacognition in AI is also prone to problems of confabulation and hallucination, and that reasoning symbolically within AI on top of the pattern matching stuff could be very useful to mitigate that. I think I belabored the point there, but today we have AI as a fallible moral butler, and it's also a good proposal generator and critic of ideas that we might have, and it might perform well, but whether it's morally capable, robustly morally capable underneath the hood is another question. Okay. So we do want to hold AI to a higher standard than humans. Sometimes I think it's unfair that we're saying, well, humans, we don't hold humans to the standards that AI are doing. But that's like an argument for, well, I mean, are humans really reliable enough to sort of, to do the kind of moral decision making that we might have to make in the future with large stakes? Maybe not. I'm not saying that we should cede moral authority to AI. Yes, I think that under certain circumstances, we may wish to, because it may be just better than us at making moral judgments, but also more morally motivated than us. So maybe it's a bit about going between the less efficient devil that we know, us humans, and trading off between the more efficient devil that we don't know, and that might be the AI. AI could be a really efficient moral hypothesis generator. It's just a side note. So now let's talk about evidence and empiricism. Today, as AI can integrate sparse, scattered findings across huge literatures. Now, AI can kind of do that now, and so might be able to augment our current. You might be able to federalize a lot of the knowledge that we have into patterns that produce useful information to us, that may be novel sort of pattern matching across different findings that we already have. So perhaps it can help discover stuff we overlooked just because we couldn't really join the dots, because all these data points were just sparsely distributed, and our context windows as humans is rather small. So many claim AI may be advanced. AI advanced scientists could be coming soon. So AI scientists, that closed loop scientists, could be really, really useful, especially in the process of understanding the seed of experience. So it would be very useful to understand how our sentience works, and how pleasure and pain works, and perhaps even qualifiable details, leaving less room for disagreement about how much something is of value or is disvaluable. So this could ground ethical claims in a new way to the real world, not only by just behavioralistically, I go ouch when I feel pain. It makes sense because you can actually measure the patterns of pain signals in my brain and know know it's pain by the shape of the pain and the pattern, by the shape of the pattern in my brain. And so, yeah, it could really help. Andres Gomez Emelson will be discussing, yes, something relevant to this subject. But last year we did an interview about valence realism, which is basically the idea that valence is real. It's not something magical that's sitting separate to the rest of the universe. It obeys the same physical laws as everything else. It's subject to the physical laws of the universe. But if it's patterns, then it should be modelable basically. So today's AI is empiricism by proxy in the sense that it synthesizes human-generated text on empirical findings and may be able to find interesting correlations. But however, there's a data wall issue that, there's the sample efficiency of AI learning isn't very good at the moment. And if we need hugely more amounts of human-generated text, then AI might not be able to get better unless we produce that text. Maybe you can get AI to help produce that text, but there's disagreement over whether that'll actually help. So instead, we should have AI as empiricists in the real world doing real science. So instead of reading about science, doing it. I'm doing both really, but future AI will do closed loop scientific measurement and intervention. So it's kind of like AlphaFold showed that AI can radically accelerate science by extracting structure from existing data, reading about it and all that sort of stuff. But future AI will be instrumented in a way that it's choosing experiments, running them through automated labs or sensors, analyzing the results, and literally doing it extremely fast, iterating at a extremely fast clip rate. I think this would be huge for welfare and ethics if we focus the scientific experiments on understanding the seed of experience, because many important questions, especially the morally loaded ones like sentience, are bottlenecked by weak proxies like behavioralistic representations, noisy indicators of what actually is really going on underneath the hood, and these indicators can be gamed as well. Sparse measurements. So there's too little calibrated ground truth on edge cases, where if AI could come in and produce more ground truth, that might bolster some of the edge cases, and such that they graduate from edge case into well-known facts about the world, or well-established theories about the world. So yeah, we need a closed system that can systematically test and calibrate. And imagine all the replication testing that could be done if this were possible. So the constraints will be whether it can be reliably do this measurement and recover from failures in this process of hypothesize, design, run, procedure, update, labyrinth, repeat. So yeah. And also, there's a safety issue of AIs being able to do this as well. So AI is premised, the effectiveness of AI is premised on the understanding that AI intelligence is power. So AI being able to affect its deliberations, or its power in the real world, comes down to its ability to take action in the real world. All right, so look, we were born surrounded by technology, for a long, long time, and it seems, we wake up in the world surrounded by phones, walls, lights, heaters, cars, and we just assume that that's part of the landscape. It wasn't always the case. Technology doesn't grow on trees; it jumps out of heads, out of intelligence, rather fast, like jacks from a Jack in the Box. So yeah, thinking outside of comfort zones. What do you think it would have been like if you were born, like, 100,000 years ago, before modern civilization or agrarian farming? Oh, the agrarian revolution probably wasn't all that nice to the farmers either. There was probably a lot of sickness and death and as well. But in any case, intelligence is powerful. With our intelligence, we've bootstrapped from, hunter-gatherer societies to walking on the moon, developing drones, developing AK-47s, and in the near future creating super intelligence, smarter than human intelligence. We already have AI that's smarter than humans in many ways. It's like a jagged waterline of capability. AI is definitely better than us in so many ways. So yeah, I mean, I can skip this slide because I think it's just really, this slide is just saying that natural evolution produced humans in glacier timescales. Intelligent design, that is, AI is intelligently redesigning themselves, could be a lot faster than evolution evolved brains. Okay, so yes, intelligence is powerful. Force multipliers leverage intelligence, leverage optimization power. So yeah, we see this all over the place. It's just an enhancer of productivity. High resolution brain scanners, faster computing hardware, as Lev in the audience might appreciate, exotic forms of computation, improved algorithms, and maybe even improved philosophy. So yes, I mentioned I.J. Good before. His partner in Bletchley Park was, of course, Alan Turing. So he said that it seems probable that once the machine thinking method has started, it would not take very long for it to outstrip our feeble powers. At some stage, therefore, we should have to expect machines to take control. So, I mean, if we take his words seriously and give them weight, then yes, we should be expecting AI at some stage to take control. Even if it's partially, we should be concerned about how they are motivated. So on we are to moral motivation. So how should we align AI? Should we align it to human values? Can we just specify exactly what to do? Can we domesticate AI like pets? And so how can we be confident about which values we should be loading into the AI and which ones are going to be future-proof? So the new LLM AI systems have consumed the majority of human text already, as I've mentioned, something like 1 trillion words of text or more. Novels, textbooks, scientific papers. So the challenge really isn't about getting them to enough information about ethics. It's about making them care. Although I would say that if once they do get sensory data, better sensors and actuators, and can work in on the field in the real world, then they may be getting very relevant information about ethics. So, but yes, this is Toby Ord. He's quite famously wrote The Precipice, and it is in the Revisited. He make this quote here, which is very important. So where are we? Yes, motivation and values. So Claude Constitution and the Soul Spec. I thought they were very good reading, and I'd say that's a step up from where I thought we were with Frontier Lab. But arguably, there's a lot of direct specification happening there. This is important for moral progress, but it's not the only thing. Yes, I think there was also, through reinforcement learning, a kind of domestication going on. But this is all about, getting the AI to reason capably and perform morally well. But it may not mean that they're actually competent moral agents underneath the hood, or that they're truly morally motivated, which is very important. Yeah. So yes, it's you know, this has been all over the news. I won't belabor the point, but yes, it's good that some LLM companies, frontier companies, are standing up and holding fast to their red lines. I'm not saying they're perfect, but you know, it's great to see some pushback. So we need inner alignments as well as outer alignment, and I've been referring to outer alignment quite a lot. So we need inner alignment, you know, and I think that comes down to motivation rather than just rule specification. So of course I've brought up this proxy values example, which service human needs while nascent, but at scale do something completely different, often inimical to our interests. This is exemplified in Goodhart's law. So we need in alignment. So alignment to what? Human values. But we know that humans aren't necessarily aligned with each other. So it may be a very difficult target to specify. It may be a very confusing target to align to human values because we're incoherent, inconsistent, in conflict with each other. You're affected by motivated reasoning. We're warped by self-interest or ideology. You know, we're influenced by Overton windows, you know, whatever's, you know, in the news at the time. We're partial. We're prone to anthropic distortions. My tribe first sort of thing. So, yep. Human behavior may be a good baseline, but it's too difficult to bootstrap alignment efforts from a blank slate. If that's the case, then maybe we can start with human values, but it can't be just the end point, I think. So human values are complex and ambiguous, yes. So we can't really rely on directly specifying all these. It would make it very hard to translate into some cohesive value system. It seems LLMs are very good at learning values quickly, but that may not be the right ones. Dan Hendricks wrote in his writing, and Bostrom's interview with me brought this up. AI can seem to learn human values adequately through pattern matching is maybe wrong. I don't think that it can do that. I think it still needs reasoning and grounding. So I think what Dan Hendricks was saying is LLMs seem to converge towards liberal sort of values. And so one could say that this value problem is still a problem. This value loading problem is still a problem. Well, I'm not really sure about the term value loading. It's not like we're uploading values in the sense that we load a database or anything like that. It's more like modeling the values, or either directly or indirectly, as I'll touch on later. So do we want to replicate human judgment even when it's bad? Well, humans aren't aligned. We can't really directly infer from human behavior, aggregate human behavior, very precisely anyway. Since humans aren't aligned and aren't internally consistent, like, you know, we may think that smoking is unhealthy and we may want to be healthy, but we may still smoke, or we may want to avoid the likelihood of diabetes, but we're still eating Mars bars or whatever. Yeah, so humans think weird things, value weird things, and base these values on weird things. So how can AI consistently and coherently align with human values if they are inconsistent and in contrast or contest with each other? So yeah, we have inconsistency between our stated values, what we think is good, and what our revealed values or preferences are, and how we actually behave despite our stated values. Right, so should we feed in AI our stated values or our revealed values? If AI just learnt morality by the way we behave, that might be bad because we don't necessarily behave well. If AI, even if AI learnt from our stated values are inconsistent often, and we disagree on what they should be. So yeah, even if the technical problem of AI control is solved, we still have this massive human problem. Yeah. So it's important, and I want to drive this home. It's really important, the way ethics, in ways, I think we should be sort of aligning with some kind of objective phenomenon. It doesn't require moral realism, but maybe if something like moral realism or like something like it is accurate, it sort of intuitively follows that we should be grounding ethics in reality. But then the goal of alignment could be seen not merely as aligning AI to potentially varied and conflicting human values and preferences, but with objective moral phenomena, in as much as we are confident that we get the facts about what this objective moral phenomena is. So, yeah, it's hard aggregating the messiness of human values, right? So, throughout history is a great example. There's been a lot of drift or change in what people considered as moral. So, can ethical machines be more moral than us? And I'd argue yes. And here's why. So ideally, moral authority shouldn't really sit with one human or a singleton. Maybe it should be distributed across whatever system most is most reliably good at producing good outcomes in a verifiable, fault-tolerant way. And that may be a singleton AI, maybe a quorum of AI, maybe a cyborg Leviathan. With humans and AIs cooperating together. Though we aren't really clear on the ideal decision-making procedure is, but we can be epistemically humble about our current approach to it. And this is really important for corrigibility and preventing lock-in to suboptimal states of affairs. So we need to be careful. Let's let the principle of epistemic deference remain high among the values in AI, the ranking values in AI has. So we may be fuzzy as to what we want ourselves, or what's in our best interest for humanity, or all of sentience, or what's in the interest of future agents. So we don't want to really lock in any final decisions. We want to maximize the likelihood of okay outcomes, where we're still able to steer away and beyond these okay outcomes to even better outcomes once we know more about what's possible. Once we have plotted in more detail and finer granularity what the moral and value landscape looks like. So I'm arguing that if it's hard to directly align with what humans want, and it's hard for humans to directly align with what other humans want, then maybe we need to indirectly align. So I call this indirect alignment, where humans and AI align with each other via grounded values in the real world facts, reasonable convergence, stance-independent truth, game theoretic constraints. So this is really important. I don't think this indirect alignment is a common term. I may have actually coined it. So if you hear it out there in the wild, I'd like to know. I haven't found it. So indirect alignment via objective reality. By the way, yes, most experts in ethics and moral philosophy do lean towards moral realism by quite a significant margin. So that's important to know. So yes, we want objectively informed value choice. So how are we to decide which principles or objectives to encode into AI, and who has the right to make these decisions, given that we live in a pluralistic world that is full of competing conceptions of value? Is there a way to think about AI value alignment that avoids the situation in which people simply impose their values on others, or in which there's value clashes? So I argue that maybe pluralism is a good input layer, but then we need reasoned principles, grounded reasoned principles that refine whatever we get from the input layer. So as a processing layer with reasoning anchored in objective facts and principles. And I think AI could really help with that. So yes, and this is if we had to take moral realism seriously, then AI could align to moral realism, and of the landscape of value that includes of all the circle of moral realism that actually exists, part of our higher values are likely to inhabit that circle. And I believe that we might influence AI to prioritize aligning to the aspects of moral realism that we align to. So that might bias the likelihood that we're able to more efficiently or more comfortably transition to higher moral orders, or traverse the moral arc, or whatever. And so, yeah, this is important. Moral realism does seem to have a lot of parsimony going for it as well. Not only one authoritative point of reference, and yes, it is reality. So if we have a point of reference and that's reality, that's hard to negotiate. Reality is what it is, right? You may disagree with what it is, but it's grounded and you can test it, and you can zero in on clearer explanation as to what reality is actually doing. So I think that's really important. So other meta-ethical frameworks like relativism need to account for every single perspective, and that clashes between them too. So if AI is meant to ground to all the different relativistic viewpoints of humanity, that might cause a computational explosion, and also result in a very incoherent moral outcome. So yeah. So look, I'm not saying that circumstance is not to be considered underneath the moral realist view. I think circumstance is very important. I think moral realist utilitarianism that is context sensitive is the way to go, but that's just my opinion. Okay, so the landscape of value with the acronym LOVE. So yeah, we want objective value space. So we should seek to traverse and understand the landscape of value through empiricism and reason, and that acronym is LOVE. So think of all these possible values: compassion, justice, and freedom, flourishing, even domination and cruelty as being bad points in the landscape of value. They're peaks and valleys. So bad meaning a valley, and peak meaning good stuff in this vast landscape. So some regions represent higher ground, right, where beings thrive and suffering is reduced. And other more dangerous regions, like where bad stuff goes on, where there's perpetuated, suffering, where there's unfair social structures and stuff like that. So harm, value lock-ins. So yeah, so we want to be able to traverse and understand and plot the landscape of value before we start traversing it too fast. Otherwise, what we're doing is morally drifting without where we were going, and we could end up blindly stumbling into a tractor basin of bad value. So yeah, we want a far future utopia where there's a very, very high point, but we may not know how to get there. We may know only how to get to nearer or easy to navigate points of value, or peaks in the landscape of value. So yeah, so the concept of non-arbitrary objective value space for understanding how to navigate to more valuable worlds. So some value configurations are more stable, some have more force of attraction, and may cause AI to be sucked in naturally towards them. Some, rather than, this is contrary to the idea that value space is completely arbitrary and AI will just pop into some value space and just randomly and exists there for time and all eternity. So but importantly, if AI just pops into the value landscape, how much does the starting trajectory at where it first lands matter? So landing somewhere in the value attractor space matters. If it lands next to one of these undesirable attractor basins, it might get sucked in very quickly. If it lands next to a good one, it might traverse up this utopic sort of peak in the value landscape just by force of reason. These are, of course, metaphors. I'm not saying there's actual physical value landscape that you can walk across with your own feet and, be able to plot by taking measurements physically. It's logical with consideration of the moral features in the real world. So yeah, there are dimensions and axes in the landscape of value that are of interest. So yeah, so epistemic ones, we normally accept those. We want better arguments than worse arguments. We want more efficient means of discovering truth than worse ones, more reliable ones. So I think we also should want more efficient, more reliable, and more accurate moral oughts. So yeah, it's important to mention sort of value. So yeah, if an AI is smart enough, sophisticated enough AI may be able to sort of self-locate in the landscape of value by mapping the landscape of value beforehand, before digging its heels in too quickly or dipping its toes in too substantiatively, and therefore would be able to navigate towards nicer regions. And so this matters because it might reduce the likelihood of premature lock-ins, and it enables value learning under uncertainty. It's core to this idea of indirect normativity, which I'll hopefully have enough time to bring up. So yeah, ideal advisor theories, safe value extrapolation, all that sort of stuff. So it's foundational for the idea that AI needs to be a moral learner. And we've noticed in studies of AI now, or at least recently, that AI seems to be just as confident in answers to questions that it gets wrong as to answers to questions that it gets right. So there doesn't seem to be much, calibration going on there. It seems to be confident in whatever answers it might give. Well, that's based on a previous study. I don't know, maybe it's a lot more circumspect now, but with chain of thought as well, that might help. But anyway, so these attractor bases, we want to max epoch to okay outcomes. So maximize the probability of an okay outcome and sort of maximize the probability of achieving the best outcome. We also want to minimize the possibility of arriving at catastrophe. So there's we don't want to like increase the risk of failing by aiming for this great attractor basin first. We should try and optimize for achieving whatever has the most likely probability of existential security, achieving some kind of like stable attractor basin, value attractor basin. So yeah, so these attractor basins, they illustrate states and landscape of value. Once a society or AI fails to coordinate well, or to, if it gets sucked into this attractor basin, that's the end. That's game over. You're stuck. So, well, but getting, if you plan your trajectory well, you get to an attractor basin that can mean stability, cohesion, and convergence of shared values. So that's important. I hope my microphone doesn't run out of batteries. So yes, this means we should basically steer towards good outcomes. This is what a good attractor basin might look like up close. So good or permissible attractor basins have a kind of okay landing zone, so that they're good. This basin wouldn't be the ultimate utopia, but it's a stable, achievable place on the landscape of value from which to use as a base to to navigate towards something better later. So a pleasant hilltop on which we can pause, do a long reflection, and figure out how to move towards something more ambitious later. And this is an example of a bad one where there's lock-in, suffering, and all the stuff that we don't want. So it's a, yep. So how do we get there? Well, how do we know how to, what kind of value attractors we might want to navigate to first? What kinds of, what the actual terrain looks like, and this could be done through indirect normativity. I'd say we all already have a pretty good idea as humanity right now. We have a fair idea, but there may be some ways in which we're missing the point, or we're not seeing something clear enough. And so direct specification and domestication as motivation strategies alone might not be good enough, but it's worth trying indirect normativity. I think one of the main problems with motivation selection via indirect normativity is ensuring you've got a good enough norm picking procedure. So this requires us to update our epistemics, so get better at picking norms. So yeah, all right, so that's important. So yeah, I mean, why? Obviously, I don't think I need to say why, but I think we've already got examples of what AI has helped us with. We should let AI help us with this norm picking procedure, indirect normativity. And so this goes to the question of how we get to superintelligence that we might want. What kind of superintelligence is the superintelligence we would really want, and all that sort of stuff. So, but we can't be really sure about what we'd really want because we're not smart enough to know, basically. So we should specify a process for deriving moral standards in areas where we're not justified about being confident. So then we should build a system that's motivated to carry out this process, and hopefully moral motivation will help there. And to adopt whatever standard the process arrives at, which likely will include a blend of reliably good human normative standards. So yeah, the final goal really is, yeah, and of course it should be fault tolerant and gracefully degrade and incorporate epistemic humility. But yeah, the final goals that that are given when to AI in these examples could be along the lines of achieve what we would want to have wished AI to achieve if we had thought about the matter long and hard. So it's kind of like, idealized reflection. So this is similar to what Yudkowsky's coherent extrapolated volition leverages. So its promise lies in the fact that it could let us offload to superintelligence much of the difficult cognitive work required to carry out a direct specification of the appropriate final goals or super goals. We're not going to know that in the near term. This may help us get there, if ever. There always might be some unknown, so we may never really know what the final sort of solution is. But in any case, let me just run through this map. So we have a citizens assembly. I haven't decided how to do that. What a citizens assembly would consist of. I believe it should be good, motivated people who have expertise in moral philosophy, different people with different backgrounds and all that sort of stuff, and with different interests that represent people across various domains, also animal welfare as well. So first they seed with starting values and norms, and this may be the pluralistic initial norms that get seeded. AI then it consumes those, goes through a process of idealization. AI extrapolates, cleanses them, removing biases, updates epistemics, priors, and decision theories. This isn't all about morals. This is about like epistemic values and all that sort of stuff. So it's in the process of doing that, it may improve the process in which we go through the next round of indirect normativity. And so, yeah, update decision theory. So, yeah, derive the normative standards. This is the next part. So once you've got those, you then forecast based on these derived normative standards what the future might look like. This is when you make predictions and plans. And so best guess forecasts on the social configurations of X, Y, and Z. And so, yeah, this may turn standards into predictions and plans for candidate social configurations, multimedia scenarios of what the future might look like, dome cities on the moon, O'Neill cylinders, or, given these normative standards, maybe we want to avoid them because AI predicts that you will be in apocalyptic hellscapes. So yeah, then once all these have been done, you got statistics like lives saved, QALYs, DALYs, all these sorts of things. Minimum, average, maximum well-being, risks averted, stability score, freedom score. Maybe it might say, oh, here's something you didn't think to consider in your initial sort of norms. And maybe even a sample, like a hedonic sample of what post-human psychology might look like under these conditions. And then you send that back through this feedback loop for citizens and maybe in liaison with AI to ratify. So if it's ratified, then go ahead, build, update, build the utopia, build the AI that can actually create this utopia, right? Re-implement the normative, the updates, the patches, the improvements to AI's decision theory, AI's epistemics, do all of that, right? And so there may be some things that we ratify. Maybe we don't build utopia first, but we update AI to be better at deriving predictions and forecasting and reflecting. Do that again and again and again until you arrive at a safe place. We have like a reliably existentially secure civilization. Yeah, and then one that's good enough that we're all happy to migrate to. That's indirect normativity. Very powerful. Undervalued. I think it's chapter 13 in Nick Bostrom's Superintelligence. I think people get tired by the end of the book, but I think it's the most inspiring part. Yep. Anyway, read Superintelligence if you haven't already, especially chapter 13. So yeah, we don't want to be overconfident in our final values. I think it's just reinforcing epistemic humility. I want to say something again about iterated long reflections, and this is like embedded within this indirect normativity process. So we may start off with something like adequate alignment that gets us as far as reducing the likelihood to acceptable thresholds so that AI might not kill us all. But then that might be an oracle level AI, semi-intelligent, super-intelligent oracle. Then we might use indirect normativity, including long reflections to update what that AI might be. It might give us ideas on how to achieve existential security, the next level of utopia, better superintelligence, and also how to do another long reflection. We've got all this scaffolding to achieve an even better long reflection. More existential security, more utopia, more long reflection, more existential security, utopia 3.0, and update, lather, rinse and repeat until we achieve it, the best possible utopia. That could take some time. Who knows? Maybe we'll join the cosmic collective, or if we're alone, enjoy our captured share of the universe for the next 100 trillion years, or until beyond the heat death of the universe. Yeah, maybe we need to be part of the cyborg Leviathan, where we're part of the system, where we are still instrumentally useful for it. And also, evolving with AI might mean we have access to reservoirs of state spaces of experience that are far beyond what we can imagine today, or that we don't have access to today. Yeah, so that's basically it. Although I will say one more thing, and that is, I spoke about this with some of the other participants, and that is AI if it's powerful enough, might be able to predict shelling points in the landscape of possible value that all the other mature superintelligences, or at least a large majority of them, may inhabit. And therefore, it might make a kind of value handshake with that future, timeless value handshake with this future value configuration, in anticipating of having a frictionless acceptance into the cosmic collective. That's it. Thank you. Yeah, hopefully everybody's still there, and I still got a microphone left. Okay. Any questions? I think, yeah, Lev had to go. But yeah, thanks everybody for participating. If you have any questions and you're not here right now, just write them to me.